Yeah, so hi everyone, welcome to the AECtech 2021 How to Build a Web 3D Viewer workshop. This is Hanshen's son and Amit.
Hey everyone, this is Amit.
Yeah, I want to mention that we have a Slack channel for this workshop. So if you have any question, feel free to put your question into the Dream Central chat or the Slack channel. We'll be responding to those.
Okay, so through the course of this workshop, we are trying to work towards building something like this. And we'll be covering multiple technologies and multiple stacks in the process. To have a quick look of what the final thing is going to look like. This is the final viewer that we are intending to build towards. So as you can see, it's running in the browser, and it's a 3D file that was uploaded to this app, and it processes whatever's in the file, renders it in the browser, and makes it visible, accessible to everyone. Towards the end of it, we'll be covering more information about storing and organizing the information in a proper way, so it runs like a stable app. We've got a couple of sample models uploaded. So we'd have some behavior similar to this, where you can load up different 3DM files and have some basic interactions going with the file content. I think we're going to cover a lot of ground today. Our hope with this workshop is it's fine if not everyone is trying to do code at the same time as we are. The way we have organized the repo is everything lives within this GitHub repo. You can find the links that we need in the README section of the repo. And if you click on the steps section, it takes you to this page where we have a stepwise description along with associated content that will help you navigate yourself through the entire workshop process. So even if you feel lost at any point or if you miss something, almost everything is covered in these steps. Some of them also have video instructions that you can load up in YouTube and keep following along. Since we are trying to cover a lot of ground, we've tried to space it out within a timeline, and we would like to keep the pace going with the workshop.
Yeah, so in the morning session, we'll cover how to set up a Vue front end and then tie a threejs viewer to it. In the afternoon session, we'll connect our web app to Firebase for authentication, storage, and database so that we can, instead of loading a local random model, we can upload a model to the storage and pull it down whenever we need to. We also introduce a little bit of sharing so that you can share it with your colleague.
I think this is part of the list that we shared earlier. Hope everyone has these things set up or going for them. Even if not, I think we got about 10-15 minutes more before we actually get into the depths of it. So feel free to take this time to set this up if you haven't already. And as Hanshen mentioned earlier, we are always keeping an eye on the Slack chat and the Ring Central chat. So if you feel stuck at any point, if you feel missing, just feel free to post a message over there, or it's also fine to unmute and ask.
Does anyone has any questions at this point?
I think we are good.
Okay.
And just rehashing the same steps that we mentioned earlier. The entire workshop is managed through this repo. And you can find all the content and all the files that you would need to follow along just on this repo. By repo, I mean this is Git repo. If you're unfamiliar with Git, it's just it's a nice way for software developers, and it's really useful as an organization tool as well, I think, where we have this wiki running, and the source code lives. If you check out the code, this is the stable source code, which is essentially what's powering this app right now that you see loaded on here. All of the documentation that we have, and with the steps, the snippets, the checkpoints, that's covered under the wiki section. So if you go in there, these are the steps that we are trying to walk towards. And almost all of the little bit of code snippets that you see throughout the workshop, they've been documented onto this page. So you wouldn't necessarily need to type out all of it. You could probably refer this, copy it from here. And of course, there are going to be few things that you might need to customize based on your ongoing setup. And hopefully this makes it easy for everyone to follow along. And to go through the workshop, we planned it in terms of certain checkpoints, which are essentially like a good stable state of the app after we've integrated a certain new features or set up some technology to work along with the stack that we have going. And you can find them if you navigate to the repo. It's these checkpoints. And shortly now, we're gonna demonstrate how to work with this using Git, so that you get these access to these locally. And at any point, if you're having difficulty catching up, you could just jump to this point in the workshop and pick it up from there, and everything should still work for you smoothly. And just a short description of Git and GitHub, if anyone's not familiar. We thought it's good to introduce this because of like often confusion about this. So Git is what we are using to share the repo, and GitHub is what we are using to manage and organize the content around the workshop. We use the Git branches to allow you to check out the stable states, the checkpoints that I just mentioned. And GitHub is where the documentation lives. So at any point, even after the workshop, this is going to be available and accessible on here. And we hope it's something that continues on as a document. Even ahead in the future, if you feel stuck or if you need help, we would be more than happy to help you out with any points through the workshop. Coming down to some certain few preferences, so a few things that you might see different between the videos and what we work through the workshop right now. They essentially come down to just preferences of how we are working. So command line lets you access Git to do pretty much the same things that the desktop GUI does. So, with the videos, I might have used the command line for a bit, but you could do the same things using this if you get the concepts going. And through the course of today, we will be focusing on using the desktop because it makes it easy for everyone, and hopefully everyone gets to follow along. With that, I think we are at a point where we can start talking about the app and checking into the individual steps. I would like to pause for a few minutes just to get a sense of what people expect from this workshop, or if you would like to share your background, feel free to unmute yourself and share.
I guess I could go. I am David Wu. My office is in New York City, FIDI. AEC manager. I work for NYC engineering. I have a little bit of coding background. I have a little bit of Python. I do a lot of Dynamo scripting. Do a little bit of game design using Unreal Engine. What I want to get out of this is to kind of get a 3D viewer on a browser, because that's the next step, right?
Mm-hmm.
To get all this data online, to be able to share with the rest of your clients easily. So yeah.
Awesome. My name is. Oh, sorry.
Go for it.
Sorry, my name is Amit. I'm a design technology specialist here at BIC. I've worked with Firebase before to set up a very kind of basic content management system, but I'm super excited to see how you guys are going to use the Vue front-end framework to kind of handle the UI, and then of course the 3D viewer part with threejs. So super excited to be attending this.
Great.
Awesome.
My name is Dustin. I work doing R&D type work where I build applications or will even just do like classic literature reviews at Cunningham Group. We're a firm headquartered out of Minneapolis, and I've built some applications in the past using Vue, but they've always been just front-end applications, and so I'm really interested to see how to incorporate Firebase and kind of bring in a backend.
Got it.
Hello, my name is Brandon Pachuca, and I come from the KPF UI team. I have a background as a software engineer and actually been developing applications now for several years, and been really having fun with Vue over the last couple of years, especially with Vue 3 and the composition API. I have a passion for three.js, so I'm hoping just to see different ways of tackling this problem from different software engineers, because there's so many different ways to hoist this data and to create data pipelines for 3D viewers.
Cool.
Got it. That sounds awesome. It sounds like there's a lot of overlap with the kind of stuff that even we do here at Core Studio, that me and Hanshen, both of us work in the Core Studio with the computational team. And seems like a lot of overlap with the kinds of backgrounds that we have, which is really nice and interesting.
Yeah.
Cool. So with that, I'll get started with the first part of this. No, I think we go through the node server first. Yeah.
Okay.
Yeah. In this first part, it's more like a introductory. So for everyone to get familiar with the workshop and the content around, it's gonna be a small effort where we try to set up a node server on our machines. And hopefully it's gonna be something that doesn't necessarily it's a part of the app we have for sure. However, even if you fail to follow along, or if you just wanna watch it in action, that's just good the same. I'll try to run through the steps. So that'll help us familiarize with the way that we've organized or set up the workshop. So let's maybe start with this. Okay, so I guess the first thing to get going would be to clone the repo so we can check out to a point and have something locally. So what I'm gonna do is copy the URL from here, open up my Git client. Now for me, it's the GitHub desktop right now, and clone a repository from the internet. I'll just paste this on there, and I'll let the local path be. You could have it wherever. Oh, sorry, it goes here. And let's see what this looks like in the Explorer. So this is right now what's being served on the live link that we shared, which is the completed version of the workshop. However, to start off with, I'm going to ask whoever's following along to check out to the beginning of it so we can run through these steps. What that does is it changes the file structure that you have locally going for the repo, and it sets it back to this point. Just okay. And now with that, we'll try to get a node project going. So you could follow along even in this video. Maybe let's quickly glance over the video so we know what's coming. Here I'm doing it through the command line. It could be local for you. Basically, setting up a node project involves using npm. It's not quite a requirement as such. However, that's the package manager that the Node environment uses, sort of similar to pip if you use Python, or maybe NuGet if you're more familiar with the .NET environment. And through this process, we initialize a repo in a way that it's compatible with the Node package manager. Here we set up the repo. With these parts, if you were to start a project from the beginning, this is how you would set it up with Git. However, since we already have it going and we got the checkpoints thing going for today, we don't necessarily need to follow along this. And by setting up the git ignore, basically we are asking Git to ignore a certain few files to keep to avoid from syncing back and forth. Okay, and this is the part where we set up a server. This is the most basic server that one could set up. It uses the HTTP library that's part of Node.js. And we set up a listener, and here on line number 3, what we see is a function that's called every time a request comes into the server. And on line number 8, we create the server and instantiate it and make it listen on this port. What it's gonna do is it's gonna set up a status code of 200 for each of the requests that it comes in, and it's gonna respond with hello world. And with this small setup, what I'm doing is I'm providing an entry path into this specific Node NPM based application. The way to trigger this would be anyone would be typing in npm start, which then calls this script. This could be whatever for our intents and purposes, but by stating node index.js, we ask node pass the index.js file, which contains the content that we just saw earlier, to node, and then it can execute it. So now after we run npm start and check back to our browser on the same port, we see the same response back.
And then I do want to mention that if you clone the repo that Amit showed, you can essentially just open up a terminal and then do the same thing by running npm install and npm start. You should see the same window saying hello world.
Yep. For that, I think it's this one, the second step. So workshop node server, when we check out to this point, we got that going. And now I'm gonna open up a terminal or bash. This again comes down to some preferences of people who are familiar with git bash might wanna use git bash. Or if you're more comfortable with using the Windows natives, you could use the command prompt, and you could launch that by navigating to the folder, typing in cmd, and doing this. So we have got the project set up at a point, or checked out to a point where it has the Node.js setup that we just saw. Let me open it up in our IDE. So for this workshop, we are choosing to use VS Code. Doesn't really necessarily have to be, but it makes things a lot easier for us. So if you check it out here, this is what we just typed out. You'll find the same example on the snippet, so you can follow along. And since we got the project and the package.json setup, I run npm install, and there's a shorthand for this, which is npm I. So both of them are interchangeable commands. What that does is it looks at what's inside the package.json. This one doesn't have any dependencies yet, but if it did, it would try to install those for this project locally. And then I run the command that we saw earlier, npm start. With that, we have our server going. And now if I go back to my browser and load localhost 8080, we see the same message, hello world. So that's a real quick intro to just setting up a bare bones HTTP server on Node.js. I'd like to pause for some minutes just if anyone has questions or would like to discuss anything, or if they feel just to gather your thoughts. Also like to get a sense of check if how many of us are trying to follow along, because that will help us pace the way we talk through the examples and descriptions as we walk through them.
Yeah, people say they are trying to follow along.
Okay.
Yeah. So we can keep it slow. We have a lot of time actually.
Yeah.
On time. Yeah.
That's good. Cool. Do you think I should try to like do it from scratch here once?
Yeah.
Okay.
Set up view, right?
How about going through this step that we just did? Okay. So people who are following along, to make it even more convenient, I'm gonna take a step back and go from the beginning, where we start basically from an empty Git repository that's already configured for Git, and run through the same things that we just saw earlier. But if anyone's following along, they get more time to follow along, and it would be more explanatory. So. So this one's a good starting point, where now if I check back here, this doesn't exist anymore. Let me also check this. Basically, it's just an empty repository with a README file that doesn't contain much. And now to set up the node project, what I'm gonna do is I'm gonna go back and launch my terminal and do npm init. These are the same steps that we documented in the video. It asks me a bunch of questions, which is basically the initial configuration for the npm project. So it has some good defaults. You can enter, like just enter for most of it, like package name, the version number, description if you wanted to fill it out. The entry point, we're gonna keep this empty. The test command, and a Git repository. It already senses that it's a Git project, so it has a recommendation for you. Keywords. And basically after entering that, this is what the package JSON is gonna look like for us. And if I hit yes, it goes ahead and creates the file for me, which is this one. So that's the package.json. Now, with that set up, I'm gonna go ahead and create the file where which we use to instantiate the server. I'm gonna call that index.js. And for this part, here is where, so as a simple example, maybe if you just wanna see something on the terminal window, you could do console.log. And when we pass this JavaScript file to the node engine, it's going to process the JavaScript contents inside and execute it. So coming back to the terminal here, if I execute node index.js, you see it logs whatever I did. If I update the contents of this new variable, and I'll execute the same file again. But since I've updated the file, I expect a different output. And that's some simple math going in there. Now I'll update the same file with the snippet for creating a HTTP server. For that, I'm gonna check back into the repo and have a look at the snippets. A basic Node.js server. I'm gonna open that in a new tab. And this is the same thing that we saw earlier. Just copy and replace the contents of this file. And again, just walk through it real slow. Call the HTTP module from the inbuilt Node.js packages. Here, this is the callback method. We call that in the JavaScript world. Basically, when we create a server, we pass it a callback function, which is going to be executed for every request that it receives. Two arguments go into it, the request and the response. Request contains a lot of the web stack, information about the source of the request, and a whole bunch of metadata that's attached with a lot of the web-based requests. And response is a proxy object that we use to interact with the response that we want to send out. HTTP protocol works with status codes. So 200 means, okay, this is a valid response that we're going to send back to the client. And there could be a bunch of these. So people might be familiar with the 404 response. That's one of the HTTP codes, which means something that the client was seeking from the server was not found. And we send back whatever response we want to send back. And this is where we actually start the server to listen for requests. 8080 is the port number that we're using. And that's again part of the way HTTP protocol and TCP IP works, where within your machine, it's only listening to requests that come in at this port. With this file updated, I'll run the same. Let me just run node.index.js, which is gonna execute this file for me. And as part of that execution is the server that has been set up. Now, if I go back to localhost 8080, I see the same thing. And if you're unfamiliar with localhost, that's a way your computer uses to address itself. So it's sort of like calling home at this port. Okay, now with that going, it might not show anything here, but it's still actually running the server in the behind. So to exit out of this, I press Control-C. That exits me and puts me back in the terminal. And that killed the server. Now, if I try to go back and load this page, there's no response coming back. So the browser is going to show that the site can't be reached. And now we try to set up the server to run every time, or rather call it as an NPM project. And the reason being, so as part of a node project, you could have multiple scripts, all of them doing different things. We're gonna use this feature a little further down to have a different script to build files and a different script to set up the dev environment. That will become more clear as we go ahead. But for now, let's just create a method or a script called start, command called start, where we call the same thing that we were just typing out into the console. It's a nice shorthand as well. If you're using some command repetitively in your project, people often make scripts out of it and put it at this place. Now when I do npm start, it does the same thing that it did a few seconds ago. And now since we have the server going, I do expect a response back. And let me refresh this. There we go. A quick thing to note might be while it's running, and if you update the file, it doesn't necessarily see the changes that you might have made. So let's jump back to the file quick and try to update our response. However, it's not gonna see that because it already has the server running based on what we passed in earlier. For me to restart, if I restart the server, it's gonna pick up this change. So if I kill this, which is Control-C, Control-C, and then call it again. And now I expect this response to change. And there we see. So with these few steps, we covered setting up a npm project, like a real quick basic npm project, passing a JavaScript file to the node engine and basically calling a JavaScript file in the node environment. And third, setting up an npm project to execute a file when it's triggered. Start is a special script in some ways because a lot of the existing web frameworks and even services just assume the start command within an npm project to be the default command. So we're gonna see more of that as we keep progressing. But yeah, I think that essentially covers the first step for us, which is just setting up a simple HTTP server. As we progress, we're gonna enhance this to be more in depth and gonna serve different ends and purposes. We'll be installing node packages. We'll be setting up build processes. We'll be serving files using the server that we just set up, and like so. And I'll stop a few moments if people want to try this out and have any questions to post.
Yeah. Does anyone has questions about the first step, setting up the node server?
Okay, someone says everything's seeming good.
Okay.
That's good to know.
Yeah, I guess we can jump into the next step a little bit earlier.
Should we? Let's pause a few minutes if anyone's fine. Yeah, we're leaning on to hear back. Like the online format of doing workshops has its certain few challenges. This would have been easy to get a sense of the room if we were doing it in person. But if anyone's stuck or if anyone needs help, feel free to reach out. That's good to know. Should we try to share the comments on here? But Ring Central doesn't let you do a chat window, right? So
Yeah, I don't think the presenter can see the chat, but everybody else can see it.
Oh yeah. Okay.
Do you want to go over what Vue is while maybe people are still wrapping up the first step?
Yeah. I thought like that doing it like let's wait. Okay, let's wait till like 10:42 on our time. I think everyone's gonna be in different time zones, right? We are in New York time zone, so if I refer times, hopefully you can see the screen window and we have it show up here. That's the time we might keep referring to.
Yeah, I do want to mention that the morning session goes from 10 a.m. to 1 p.m. and then we're going to have 1 hour break, and then in the afternoon sessions from 2 p.m. to 5 p.m. using a different meeting link. So just to be aware that in the afternoon section, there'll be a different meeting link, and then you can find the link in the email I sent out last night.
Okay, I'll wait another minute and then get started with checking out what Vue is and how we can set it up for our project. Okay, yeah, I can post a link to this one.
The meeting link? Yeah, I'll do that.
Maybe post a link to the Slack.
Okay.
I think yeah, the meeting link.
Yeah.
Be worth mentioning just so that everyone's sure, like the sessions are also being recorded, so they'll be also accessible online later, in addition to all the content that you see that's being shared.
Yeah, we're recording this and we'll be posting it onto YouTube later in a couple of days once we finish editing. So
yeah.
Once it's uploaded to YouTube, we'll email everybody with the link.
Okay. And Athar was just asking if we could share the YouTube link. I presume you mean the links that we have as part of this content. If that's the case, like they've been recorded as multiple different videos, so it's not one link. However, you can find all of them if you go to the repo, go to steps, and within these sections, they point to all publicly accessible video links. However, it's difficult to like post multiple YouTube links, and that's why you can always check it out from the steps. Okay, I think with that we'll start in talking about Vue. Okay. So what is Vue? Vue is this stack that we use on the front end to help simplify and making front end development easier. If I were to speak like very absolutely, you don't really need Vue to build web apps. Anything that you could do with Vue, you could do with native JavaScript and the HTML. However, Vue does a lot of things for us, which makes life much simpler to manage. And also when working in teams, it's easier to think of the apps in terms of Vue. So it tries to follow this paradigm based on component-based development, which essentially means the different parts of the page are broken down into smaller chunks. That's easier to manage, easier to maintain, and easier to reason about within their small units. And Vue lets us do this by trying to encapsulate the template, which is the HTML part, the logic, which is contained in JavaScript, and style. I'm sure, I think Vue also supports TypeScript, but I'm not 100% sure on that.
It does.
It does, yeah, okay. So it helps us keep all these three different parts which go towards making a web page or a part of a web page in individual and encapsulated files. That's not the full scope of it. There's more of it. And in terms of comparisons, like Vue is similar or more like alternatives to Vue might be React.js or AngularJS, and there's always new ones coming up. However, it's sometimes difficult to make apples to apples comparisons because in terms of the features that each of them individually support vary a little bit here and there, and the way they approach it is slightly different. So where they draw the lines in terms of the boundaries of what you can expect from the stack differs a bit. We've been using Vue a lot with our projects. And so basically, when we look at a page, on the back end, the page is contained in the memory or processed by the browser as a what's called a DOM tree. So if anyone's familiar with the HTML structure, basically this is how the content on the page is laid out. There's the document which sits at the top level, and all of the individual tags, the way they are nested into each other, help the browser engine build this structure. Let me try to zoom into this image. There we go. So a basic HTML page, when we write out the HTML for it, is processed by the browser and converted into this representation for its memory. And this forms like a tree structure within the app. And Vue sort of works on top of this, like uses this to update the DOM tree at the right time whenever a change from like user input or any other aspect changes. Like it updates the DOM tree in a neat way, allowing us to write the code. Okay, so this illustration hopefully helps make our point clear, where each of these blocks essentially refers to the individual nodes of the DOM tree. So as an example, we could consider this to be the HTML or the main parent, the root element, the header section, the body, the footer, and they further have other children that's a part of them within. And Vue plugs in nicely into this framework where we could write these individual components as individual files. This isn't the full, I wouldn't say this is the full picture because the HTML and those layers, they are sort of like one level above, and Vue embeds itself within one part of this. You could customize it to behave different, but coming from the default and most of the users of Vue, it ends up being part of the body where we have the main application logic. And to look at the structure of what a Vue file looks like, so we have the template part that we just spoke of, right? That's the JavaScript that shows up. Some parts of this are hard-coded. So an example like this, in this, the H1 is never going to change. And what's encapsulated under these double curly brackets, they are what sometimes people refer to as like reactive elements of the DOM. Let me move it to this side. So within the template, it's gonna show whatever the value of this variable is. In the script tag, we try to contain the logic, and data represents all the information or most of the information that has to be represented in the template in one way or the other. We'll see more of this in the example that we work through, so it's fine if you're not fully following along. It'll make itself more clearer. But this will help you lay out a structure of what it's like, and you'll see what the different behaviors are. If you've done any bit of web development, CSS, cascading style sheets, is used very often to style different elements. By that, I mean the borders, the background colors of something, the fonts that we use, the fonts that within one container, the border width, the strokes, if you use gradients. And each of these, I think individually could be like a multiple day workshop on its own. However, in spirit of like trying to achieve what we want to do with the web viewer, keep it brief about all that. And So yeah, this is what Vue helps us do: encapsulate things and make it into smaller chunks that's easier to share with the team and work with. It also does a few extra things like this, where, as I mentioned earlier, like you don't really need Vue to build a web app, but it makes your life easier as a developer and as a maintainer. So on the left-hand side, what we see is a behavior that you would try to do in pure JavaScript. Basically, it's setting up an element, having an ID to it, and having some value on it. And by this logic, it's going to try to update the contents of this paragraph element whenever someone clicks the input button. So do it in pure JavaScript. It would be like wait for the document to load. Once it's done, get the my button element from the document and attach a listener to it. So whenever anyone clicks this button, again go back to the document, fetch the element identified by the ID myPara, which is this, and update the inner HTML of it to be a hello world. This would be the pure JavaScript way to do it. If we were to use Vue to do it, this is what it would look like. There's a button, you assign an on click, and you update the internal variable .content, and that's going to show up in the element right there. Okay.
There's a question in the chat asking about is Vue used over React in TT? It's in general, Core Studio nowadays most of the web app is built on top of Vue, so it's what we use in Core Studio. But personally, I also really like using Vue for development. It's pretty quick for prototyping, I would say.
Yeah, and I think when we keep trying to innovating and check out like the new possibilities that's possible. So Vue is something that serves our need well right now. However, one thing that I personally feel opinionated about is like the whole web stack keeps moving, and every few years you're gonna find something new. So we try to stay abreast with that, and Vue is something that's serving our needs well. However, it's not like we're married to it, and we are open to whatever serves us well. Some major differences between, so Mayur asked, what are some major differences between React and Vue? I'm not sure if I would be the right person to answer that question because I am not too familiar with React. However, in terms of my experience, a few things that I could comment about is the way the template files are written itself. I think React supports JSX in addition to other ways of writing templates, which are which looks something like this, where it has a slightly different approach to do the similar things that we do in React. And also there are differences in terms of the scope of each of those. Those are parts where I'm not too sure what would be like the exact comparison. So I think that's gonna differ based on your project requirements. But yeah, at a high level speaking, those are the few bits that I can share. Awesome. Yeah, nice to have these questions. It's like helps keep the conversation going back and forth. Jumping back to where we were in terms of these slides. So talking about how Vue does its thing. As you mentioned earlier, like this is native, like raw JavaScript and HTML, and this is Vue. The browser itself doesn't understand Vue. So the way Vue works is it looks at the files that we write with the Vue markup with the way they structure the logic, and then it uses something called Webpack, which basically goes through the source code that we have, converts the Vue components into a JavaScript compatible, like a native thing, and spits out files. Webpack again is like a whole world in its own. There's a whole lot of things that it can do for you looking at your source code, and it's, I would say, the most popular thing that's used for building front-end applications right now. And some of the major benefits that comes along with Webpack right now is like when we look at our source code and build files, there's a way there are options to build files for the dev mode or for the production mode. So in the dev mode, what it does is it builds the file in memory and allows hot reloading. So whenever we update the source code on the like when we update the files itself, those changes are immediately reflected in the browser as we are testing it, which makes the development process go faster. When it tries to build for the production modes, it spits out a more optimized and refined version of the same thing, of the same app that we have. And in the pipeline, you can set up more things. Like you can set up things like obfuscation, which will make your logic more secure. You can, in addition to the native optimization that Vue does, you could do a whole bunch of things. But that's getting deeper into Webpack that I don't really want to get into this right now. But at a high level, those are the things that it does. And we use these two at different points in the workshop ahead. So I wanted to highlight that. But that's a high level quick intro to Vue. After this, we are gonna jump into the steps and try to get something going on Vue for us. Would there be anything? Okay, there are some questions. Let's have a look at that.
I think they're just discussing about the difference between React and Vue.
Yeah. People's talking about Byte and Snowpack. So that's neat discussion. Like even I've been shadowing the development of these as they happen. I'm not too familiar with either of them, but it's good to know that what everyone's using and what works out well for you. Maybe that's something even we can check out. You're doing fine on the time, right?
Yeah, pretty good actually.
Nice.
If we have some time at the end, before we have 1 o'clock, we can leave some time for questions or discussions.
Yeah. If you're doing fine, like it's the way this conversation is going, I'm liking it, like back and forth. Any resources and tutorials you would recommend for Vue? Not at the top of my mind. I mean, I'm sure as anyone who's tried to code here, like Google and search engines are your best bet when stuck with things. But I can't recollect how I started with Vue. Do you have any?
Personally, I really enjoy learning just by looking at other people's code. So a lot of times I'll just go to Google and search for a Vue starter, and then just clone the repo and then take a look and see how people are using it.
Yeah. A lot of people are talking about NetNinja and Traversy Medium. Definitely, I've come across those two channels while trying to get myself familiar with Vue. I should not Traversy Media. I think they also keep posting a lot of the other stacks besides Vue. Like in general, a lot of good content around development and setting up stacks and these technologies. Like these sorts of things if you're interested in. Okay, so with that, for the next section, instead of trying to do all the logic and typing out the code locally, I'm gonna play off of the video, which is basically what I would have done if I were to do it, but this helps keep the conversation more open-ended. Let me close what's running first. And maybe I'll start off with showing what the project would look like in the project that we have going right now if we had Vue set up. So I'm gonna clean up the changes that I have already. I could right click on these, just click on discard changes to see the difference that it makes. Let's have a look at the source code file right now. So my package.json looks like this right now. When I go back to the GitHub desktop and right click discard changes, it reverts it back to the way it was in the commit earlier. And then I'm gonna come back, check out the view setup branch. And let's eye over the package.json. So see, when I move the repository from the point that we were at to this, I can see the package.json has failed, and there's a whole bunch of extra files. I'm going to walk through the video of what these are and how we set these up in the steps. But now it has a bunch of dependencies. There's a pipeline. It has a config file. And now since I've cloned it at that point, I need to install the packages that I did. So for that, I run either npm I or npm install. Both are the same. And this install process might take different amounts of time based on your machine. And some installations have other not necessarily native JavaScript dependencies, which differ based on the stack that you have. So you might see different things show up on your screen. Okay, with that, I installed all the packages that I need. And the way I have this branch set up, I run npm run dev command. That's gonna spin up a dev server for me, serving a Vue frontend. And that's being served on this URL. So I can just copy that. I'll just use this. So it's on 80814 port. And that is the Vue frontend. So just to have a look at what the source file looks like with the default setup. There's the main.js file. Here it's instantiating the view and mounting it at a document with the ID app, and you would be able to find that in the public index.js. It's gonna mount the Vue frontend inside this div. And it's gonna pick up this Vue component. So we check out app, and here this might be difficult to visualize necessarily, but this is the hierarchy that we were trying to point to with this. So there's the app, and it has other components nested under it. Vue has a way of structuring how those components fit into each other, and I'll walk through that in the video. But I got a simple component called hello world, which the app mounts. And within this component, I'm using a raw image tag pointing to a resource over here, which is stored in the public folder. So the public is directly accessible at the root level. So images img, which shows up like so. That's the image file. That's how I look at it. That's this. And then I have a button going, which will execute this logic when it's called upon. So there's the type value of it and the click handler. So in Vue world, this is how we use to associate callbacks with button events, or rather when the button is clicked. And the way it's defined, it's a method which lives under the methods object as part of the script tag. Let me check one thing real quick. Okay. And this is a finish point. Through the steps, I go through a couple of things, like the raw view setup and connecting it to a backend, the Node.js backend that we just saw in the last step. And now when I use this, that makes a call to the backend and comes back. Now, I wanted to show this as part of what we are actually building in this step. And now I'll open up the video to go through the setup steps. So for the beginning, we got, let me check the questions real quick, if there's anything. Also related, if your app is self-contained and you don't want to mess with managing a middle and node apps setup on a front end, Nuxt is really good. Yeah, I keep hearing good things about Nuxt too. Never got a chance to test it out myself yet. Coming back to this. Yeah, so for the beginning, I got rid of the file that we just had going, the index.js, which was serving a raw npm or a raw node server. And this is the part where I'm setting up the Vue CLI globally. So for node projects, you have packages within your project, and then there are packages that you can globally that's accessible for in your development environment, though they are installed somewhere in the app data folder. And those, so the Vue CLI is something that's going to help us scaffold a Vue project. So to begin with, we install Vue CLI. Okay, and there it has installed all of these world of packages. And since we already have a project going, this would be the way I would instantiate a project in an existing NPM project, a Vue project and an NPM project. If you didn't have, if it was a pure thing, pure Vue.js project that you are starting from scratch, it would have been Vue create and the name of the project that you want it to be. All of these snippets, you'll find it in the snippet section that we were referring to earlier. So you won't necessarily need to type it out. But for an existing project, I'm going to do Vue create dot. And that dot means like look at the current NPM project and try to set up a Vue project for that. Similar to how we had it for NPM initialization, it's going to ask you a bunch of questions for the initial configuration. They are actually pretty significant in terms of how the project behaves and performs. I'm not going to go into the depth of all of it. However, to speak at high level, Vue 2 is what we are using right now for this workshop. Vue 3 is something that came up recently, and the way the components are structured are slightly different. It's mostly the same, but they have something new called the composition API, which helps you do a certain few things more, and it's optimal in a certain few ways. And at some point, it's going to ask for Babel. Okay. So if you're following along, these steps are something that might take a bit while depending on your machine. In the video, I've tried to edit it out and keep it brief. Okay, so with that going, with just the raw or like the bare bones Vue setup, after we have it installed, we go into the project. That would have updated the package file that you have, like the Vue CLI updates your NPM files for you. And we'll come back to see what it means in a bit. But when we run npm serve, this spins up the Vue dev server. And by dev server, that's the mode where it does hot reloading and build in memory and a bunch of other things. Okay, now with that setup, it's gonna serve it at this. If you're following along, your port might be some, your experience might be something similar to this. And that's the default bare bones view setup, where it shows you the packages that you got and things you haven't. And to come back to see the kind of changes that the Vue CLI did for us in the project is it updated the package.json to add these more scripts. At a high level, serve is the setting up the dev server with hot reloading and all of the other bells and whistles. And build is what would build the final production files for us, which we will come back to later in the step. And it has a whole bunch of other dependencies that Vue needs to do its thing. Okay. So in this part, I'm trying to walk through the examples of how Vue would, like how you might update a Vue project. So on the source side, I just add a new element, or as you can see, the hello world application, I added a new tag to it. And as soon as I save this, it just shows up directly on the front end when you view it. I'll stop for a few seconds if anyone's trying to follow along for this part. But that basically was scaffolding a Vue project in an existing NPM project. For the next part, what we're going to try to do is try to connect the front end and the back end that we set up in the last step. I'll probably wait a couple of minutes before beginning that. If you're following along, it would be really optimal to use the snippets, because almost all of these sections you can copy paste the individual things. So install, create, serve.
Just a heads up for anyone who's creating a brand new project to not use capital letters in the name. I had that issue and I had to redo it.
Gotcha. That's a good catch. Does it complain if you use capital, like no capitals?
Vue doesn't accept that apparently.
I see. Hey, it's something new.
After this step, we're going to talk about threejs, right?
Well, now we set up Vue.js to talk to backend,
Okay.
and after that comes threejs. Yeah. Okay. Hoping that everyone's following along with this. This is a part that might not be super relevant from the workshop point of view. However, this is gonna help you understand how you can set up a project so that you can talk to an existing backend that you're building on the same NPM project. The reason we have to do this is in the dev environment, and there might be different approaches to doing it. But within the dev environment, Vue has its own server that it uses to do the hot loading. So we set up a proxy where for certain routes, it's gonna channel those requests to the backend server that we set up. So we'll be starting up by setting up the backend server with a more robust framework and trying to set up a single command to set up the dev environment. So coming back to the point that we were with the Vue setup, To begin with, I install a bunch of packages. So concurrently is something that lets you have multiple terminals in one. .env is used to load the env packages. Express is the more robust and widely used HTTP server that's used for a lot of node projects. There are a bunch of options. They have different performance benefits. Express is not the best, I think, in terms of performance, but it's the most widely used and really friendly to work with. NodeMon monitors the changes to your files and restarts the node server. So it makes, again, the development process faster, because when you make any update to your backend server, it just hot reloads the server. Well, not really hot reload, but restarts the server. And with those packages set up, I'm creating a new file and server called server.js. That's going to be the entry point, sort of like what we had in the last step with index.js, but it uses a bunch of more things and it's a more robust setup. With this, what we have going is setup, basically use all the packages, read the environment variables, set up the Express server. And this is the main part of this, like the app.get. That's the way we specify routes and endpoints within the application. So for a route like /API/test, when someone calls onto this on this server, it's going to enter this callback function, and it's going to log a statement to the terminal at that point, and then return a response of test successful. And now coming back to the Vue front end, we set up a configuration that allows us to proxy or like allow the request to go through to the backend instead of having the Vue server take care of that response. Okay, we got a question from Mayur where he's asking, so for different functions, we keep on adding routes? Yes, that's how it would be. And based on how expansive your project is, that's, I think, a part where the code structuring becomes opinionated. Express by default does like a middleware based off approach where you can chain a bunch of requests one onto the other. So you can make your request pass through that. That's oftentimes useful for things like setting up authentication, setting up, checking a certain few things that you might have on request. Like, let's say there's a user who's not logged in, we redirect them to a different endpoint. And Express has a way of structuring that logic. So in brief, yes. However, if you were really setting this up for your project, it would vary depending on your project. Okay, let me step back a bit. Okay, this is the, okay, he has a follow-up question.
Yeah.
How does a single page web app work? Yes, so this is going to end up as a single page web application. So the front end is served on a single page. However, within the single page, I could be calling back different routes on the backend for different sorts of things, like get the current logged in user or get the projects that current user has. That's something we handle on the front end as another pure HTTP request. So that's a good question in terms of how structuring has changed in web development. This wasn't, I think, so common, I think even 10 years ago. But with single page applications, that logic is handled on the front end. Sure. Coming back to the proxying that we were talking about. So vue.config.js, that's a special file on any project. As soon as you create that file, Vue will identify that this is a configuration file and adapt its behavior based on this. So within this, for the dev server, we set up a proxy passing in the same route that we saw earlier. So all the calls starting with /API get redirected to the localhost server on this port. And within the script, we set up a new script. Within the scripts, we set up a new script, which is going to do a couple of things for us. So concurrently, which means in two different processes. It's gonna start the backend server and then start the front end dev server. And we also bring back the start command that just starts the backend server. And with that setup, now when we run npm run dev, we see basically what we had when we clone the repo to that point. So now we have a server, that a front-end server that's connected to a backend. And oh, sorry, this isn't quite the same point that we were at. There's a step ahead where we put the buttons and the image ahead that we saw with the clone repo. Let me jump ahead to those parts. Okay, a quick discussion about the build process. So we had the dev server going, and now we have the build process going. So when we run npm run build, it calls the Vue CLI's build pipeline, which as you can see on the console right now, it's building for production. And after it's done building, all of the application logic has been composed into these few individual files. The way this is useful is so when anyone loads a web page, there's just a single request, a single file that comes into that's served, and after that, the following logic is served on the front end.
Oh, I have one more question.
Yeah.
Now we ask, why do we need a front-end server?
Yeah, so that's something that comes with the Vue CLI setup. Primarily, it uses that for the hot preloading feature, where it sees changes on the backend, communicates it to the front end, and then updates the UI based on that. So it's primarily serving that need.
And then when we actually do npm run build, there's no front-end server.
Right? Yeah. So when we do npm run build, it's just starting the backend server and serving the front end files, not really building or doing anything like that. And this is the part where we have that setup. So when we have npm run build, we set up the static folders, which is dist. If we look into our project structure, like Vue CLI is going to build the final production files into this folder. And when it does that, and when it starts the server, it's going to pick up the front end files on that. And then the logic ahead is a part of your application. Hope that answers the question. And this is that step exactly. We had the server connected, and I think I forgot to add the start command in the scripts section. But I'll go back and add that to the scripts. Yeah, and then I edited the video to avoid that. But once you have the start section in the scripts, that now is serving, like it looks identical because that's what it was meant to be, but that's being served as the production front end app and not the dev server. So now I try to refresh and update things, but it doesn't do that because it's been built once and it's being served. No hot reloading. That's essentially the difference between like the production and dev versions for this workshop. In an effort to coordinate the time, I'll move ahead to the next section, where this is a small section. So with the backend that we saw earlier and the front end that we have going, now this step is going to build a button into the front end that's going to call a route on the backend. So I got rid of the default content from the Vue setup project, and I replaced that with something simple to get started with making the project like with my content. So I update the page to just have a hello world and a message. Oh, I forgot to start the server, I think. Okay, there we have the dev server starting up again. And once that's ready, I refresh this and we see the updated app. In this part, I'm setting up a button that's gonna use one of the Vue features of calling a method on click. So I set up an input with the type button, and for this, I have a value that's gonna be the label that shows up, and I'm calling the click method, which I haven't defined yet. But for a Vue app within the exported default object, I'd create a new object called methods, which is gonna contain a bunch of things. As the first example, it's gonna be this button clicked. So whenever anyone clicks that button, this method is called. So for beginning, let's just log something on the browser console. So that's the updated button. And the browser console is a different console than the backend console that we were looking earlier. This is just the front end. What we had in the terminal where we saw the building for production and those logs, those are the backend server. So logic from Vue or logs from Vue are going to end up in this browser console. And this again could be a workshop in itself. Like there's a whole bunch of features that's built into consoles, both for Chrome and for Firefox. They really help with debugging and managing sessions.
There's one more question.
Okay. So again, Mayur asked, he's curious to know why the method is async. That's again a great question, and we'll touch upon that in a bit. Essentially, it's this: the response that comes back from the backend is a asynchronous function because it's not a logic that exists right there. The request, it's like the backend might be busy. Network requests often take time. To facilitate that, we can convert pretty much a lot of methods to be asynchronous. In JavaScript land, it's not the same asynchronicity as you would imagine in, I think, Python and the .NET environment. It's still single-threaded. However, it's using promises. And since it's a backend request, it makes writing the logic easy. And that's the only reason I had it async over there. And truly speaking, like this doesn't fully utilize the asynchronicity behavior because this .then,
It's a problem.
yeah. So I've set it up for asynchronous behavior, but I did not actually end up using it. That's, I guess, something that I could optimize on this. But if I were to do it that way, it would be await, fetch, and this. And that makes writing and reasoning about the code and logic and as a team easier. And with that going, I think this is the next stable state we had where you click a button, make a request to the backend, it's proxied through the Vue server in the dev mode, and you get a response back. Now, with this application, even if we build it for production and run npm start, it's still gonna behave identically as it does in the dev environment. And honestly, this is like a long way to set it up. For a lot of workshop processes, it probably is not super useful or relevant to discuss this. But if you're thinking of a project that you're going to be using ahead, it's really nice to have this dev and production environment setup going and the same behavior happening at both ends. Yeah, there's some great discussion that's also happening on the chat. I think that really is a good analogy. Right? Okay. With this part, we come to the point where we were at with the view setup. We'll pause off for a few minutes right now to let anyone who's following along complete theirs. And following that, we come back to try to get threejs working. However, if it doesn't work out for you, because there's a lot of steps on this, some boilerplate code, if you feel just following along, feel free to clone the repo at this point. And we'll come back in a few minutes where we start talking about threejs. Yeah, take a quick break. I'll be back in a few minutes. Yeah.
Yeah, one thing I want to mention is that from our next step will be integrating the threejs viewer. So Amit is going to explain basically different elements of the threejs library and then how you set things up. So I think he'll take a short break and we'll be back 11:35, so in 4 minutes. I think Kareem has a question about showing the code. Yeah, I can pull out the branches really quick. So as Amit mentioned, if you go to the wiki page and then go to steps, right? Right now we're at the point where we just finished the step of setting up a Vue project. So if you check out this branch right here, and then you can clone it locally in your GitHub's desktop, you should be able to basically get the entire Vue setup with the npm run dev and the npm run build command. And then if you want to see what got changed, you can check out the commit history, and then inside the setup Vue.js, you can see all the changes that was included in the YouTube videos. Yeah, I want to mention that the entire workshop is set up in a way that you can always check out our branches that was pre-laid out for you to follow along. So let's say right now, after we're at the stage of setting up a Vue project. So once this step is done, basically we'll arrive at the result of this branch. And then the next step, Amit will go over how to set up the threejs viewer. And then if you want to just see the end product, you can feel free to just clone this branch locally and then run npm run dev to check it out. Yeah, and then we pretty much have an individual branch for all the steps throughout today, so you can feel free to follow along or even jump ahead if you want to. And then one thing I do also want to mention is that previously we showed that we have a snippet sections where it basically includes all of the code snippets you need to for different parts of this project. So if you want to know a particular way of doing certain things, you can check it out on the snippets section as well. Yeah, I was just telling them how, like, which repo to check out for each individual steps.
Okay.
Yeah.
Yeah.
And then I was telling them that at this point they can feel free to check out this branch to have the complete Vue setup locally. Yeah.
Yeah. We have a lot going through the workshop, and honestly speaking, like the first time, if it was the first time I was trying to do this, it would be a lot of content, and that's the reason we try to plan it out in these checkpoints, so they could still follow along even if you don't get it till all these points. We are doing good on the time, right?
We're just on time actually. We should get started on the threejs part.
Okay, cool. Hopefully everyone's had their time to follow along, and now we get into threejs. Maybe I'll start with showing the point that the next checkpoint that we're gonna hit with this. So let me just jump back, get into the threejs part, and redeploy the app. I would need to install packages again. And build for production. So this is something where would be at after this checkpoint, where we have scaffold, like the leftover scaffold of what we had in the last step, still pretty much working. And we get a bare bones threejs renderer in the browser that allows us to load threejs files, threejs content, and play with it interactively. And this is hooked up with the, let me check one thing.
Yeah, I see you're on the red bench.
Yeah, right?
Yeah.
Okay, yeah. And with this setup, we also hook it up with the Vue, like we set up a component to handle this. So we can instantiate things are just there and like still working well in that component and container, like encapsulated modules. So let's just start with a high level discussion about threejs. This is one of my most favorite things that I spent time, obsessively about this. Just looking through the discussion.
Yeah, I think we set up the repo in a way with the wiki, the steps, and the snippets in a way that you can always come back to this repo after the workshop, and then check it out step by step.
Yeah, it's really nice to hear that feedback because that was our whole hope with this. Yeah, so back to the threejs thing. Threejs is a front-end 3D content rendering library. A lot of words there, which just means like it's not a framework. It's not gonna do everything for you. It's not just gonna do 3D content in the browser for you. It's a library. So we build our features and functionality using threejs for whatever end we want. There, they have a really amazing website and the forum. So if you check out discourse.threejs.com, they have a pretty active forum. If you post questions, a lot of people are really responsive. And if you want to get started with the basics of threejs, this is something I like. Sure, everyone has their own thing of how they picked up threejs, but a nice content that's been developed, I think, by one of the maintainers who work on threejs. Really nice way to get started. This might be purchased. And there was another free one that I'm trying to recollect right now. I'll post a link to that when I come back to when I remember that. But that's another free one that is a really nice way to get started with threejs. So people have been building a whole world of things with this. These are some of the more like really fine ones. So often you'll find a lot of games. So this is a threejs scene where all of those individual components are like different threejs elements. However, the logic that's been built that is game specific, like the user interaction and the behaviors. That's not necessarily threejs. It's the way that they've integrated this into their app doing this. So I'm sure for anyone who's familiar with other 3D content. Like this was doable a lot for a long time, like in non-browser, but I think threejs opened this up for the web browser, where we are seeing like such games and even more amazing examples, and a lot more that you can do, and that's so immediately accessible. It's just like going to a URL. Through the course of this workshop, we are gonna be setting up threejs to load Rhino files for us. So to talk at a high level about what threejs does and the way it functions at a technical level, where here's an illustration that I've been using to try to explain how the threejs JavaScript setup works. So let's imagine this is the colored bits on this is the world that I want to show up in my browser. For threejs, it has a bunch of steps of how this gets into the web page. So for the first part, what we see on the page is always just a 2D content. So as you can see, the renderer that's on here, we call on these initialization methods within threejs to put this into our DOM structure. And then all the infrastructure that comes around it. The threejs scene contains a whole lot of things, primarily being our threejs scene that we want and the model that we load essentially. Now within the scene, we set up a camera. That's gonna be the point of view where we view our model from. As you can see here, we connect our camera to the controls. That allows different sorts of keyboard behavior and mouse behavior to be associated with this interactive experience, and allows us to navigate. On a lot of these, there are different kinds of controls that you can set up for threejs. We got the basic orbit controls going, but you could be doing different things based on the examples that they have. threejs documentation is also really good. Like, just go back here and search. So all the different kinds of controls that you would want to see. So the one that we're using is orbit controls, which is basically this behavior of click to rotate and move, and zoom to pan. Zoom, like scroll to zoom, or left click to rotate, and right click to move. And other ones have different behaviors. This is a trackball control where it tracks certain points within the frame. And different ways of controls and movements are going to be useful for different applications. For a lot of the architectural scale things that we work with, we find orbit control to be really easy for even new users to get started with. Okay, so that's where we set up our point of view and the way we control and interact. And then comes lighting. This becomes a bit puzzling for the beginning for some examples, where not all materials need lighting necessarily, but there are some materials which don't show up, like doesn't like looks black if there are no lights in the scene. And I'm sure people familiar with any sort of 3D modeling experience would have had come across this. So we got some default setup that we are going for in the component that we made, but this is something again that's going to change based on use and applications. And as a last step, we load all the content for threejs. Here, this example doesn't necessarily correspond to like what you see here, but it's an example for just loading a single sphere, which does correspond to this. And that's just a native threejs mesh. Through the course of this workshop, we are actually gonna load a Rhino model, which means it's gonna read the file, identify the meshes that's in there, and add them to the scene in a very similar way. And just to talk about high level about setting up a default rather an empty threejs scene. This doesn't this isn't a part of our application yet, but I wanted to use this chance to explain just the default setup, basically going through what we did and what a pure JavaScript native threejs setup would look like. I'm trying to use JS Fiddle, which is just a way easy to share code examples or JavaScript examples. And the example that this is part of the snippet. So if you feel like you can check from there, you can fork it, use it however you want. So for intro, we set up a renderer that does the converts the what we see from the camera and embeds that into the browser. Under the hood, that's where a lot of the magic happens, where I think these days it's the WebGL one that's the most maintained and well supported renderer that it uses. But earlier, I think it used to support Canvas renderer and a bunch of other things. But here you see we hook it up with the web page. We set up our scenes, set up the control in the same way, and you're going to see the changes on the right hand side here on the white part as we do. Setting up the lights and our access helper. This still isn't going to show anything because there are certain few methods that we need to call for the threejs render loop to actually start kicking in. And these are some utility, some convenience features where if you resize the window, it's going to try to readjust the frame of the scene. And here we set up the render loop where request animation frame, that's a browser method where we pass a method to the browser to call on every time a refresh has to be requested. And render.render updates the scene, the 2D output of what the camera sees. And here we have still only initialized or like defined the methods. And further down, we're going to call them. So initialize is going to be the first one where we set up the scene, and animate is going to start the render loop. And that puts you in this interactive environment with the access. And following this, there's this small part where I'm adding something to the scene. So the way raw threejs geometry is created is 3-dot sphere geometry. That's the native threejs geometry. And you'll find a whole bunch of these again at the documentation. So natively it supports a bunch of these geometries. Some of them are like really interesting for different applications and purposes. What is the parametric? That changed. Yeah, here's the parametric one. Okay, we have examples, but this is the snippet that we are using. Create a sphere geometry, and in the documentation they have, it's well documented about what each of the input arguments essentially are. So it's the radius, the number of segments, and number of heights. They differ for each geometry type, and that's something we figure out as we keep building. So for our example, we are just adding a geometry with this material. So that's something worth mentioning. Like the mesh is different from the geometry. A mesh comprises of the geometry that it's going to render and the material. Material has properties about a whole world of things, like you could do bump maps, you could do the glossiness, the way it appears, the way it renders. And geometry is basically the vertices that, if you may. And then we add the mesh to the scene because that's what shows up. A geometry by itself without a material is something 3JS can't quite understand. That's just walking through a basic 3JS setup. And now let's try to check an example of what creating a Vue component for 3JS would look like. So we jump back to the point where we were at with our application. And here we start creating a new component that we're gonna call 3. Yep, that's the component that we make. So setting up beginning with a empty Vue.js component. So with this component defined, let me actually increase the play speed a bit. So this is the way I'm nesting the component that I just created into the one that was already there on screen, the one called Hello World. Taking out the image that we had there and replacing it with the 3JS scene. It doesn't have anything 3JS yet. We just have the label over there to make sure that our component did get imported correctly. And setting up the default 3JS Vue setup. So these are parts where I'm trying to pass in arguments into the 3JS, into the Vue component, where, okay. Yeah. So props is another Vue feature, the way to pass things into components. So as you'll see here, in the parent component, I'm passing these two inputs. And in the child component, I just have it rendered as a list. And if I update it from the parent, it updates at the lower level. This is again more of walking through Vue.js features as we get deeper into 3JS land.
Oh, you want to slow down a little bit?
What?
You want to slow down a
Yeah.
little bit?
Okay, sorry. Now moving between props and data. This is again more a discussion about Vue behavior. Is this again too fast? Let me actually start. So props were things that the parent component passes down to the children, and the data is actually the internal state of a Vue component. Props are often useful to pass in, like use the same component, but we could deal with it slightly differently. And it allows a one-way communication between the parent and the child. But data is the encapsulation of the internal state of any component. And again, using yet another Vue feature, all components have certain lifecycle hooks. So they are things like created, mounted, destroyed, and before destroyed. Those are things that Vue just calls those methods in different states of when it's being embedded into the DOM structure or being taken out. And we use these different events or lifecycle hooks to set up the 3JS scene. So helping understanding the way the lifecycle events work helps us progress to setting up the 3JS scene so that it shows up correctly when loaded into any other component. Here again, it's similar to what we had before, where I'm changing the internal state and it's going to reflect the change on here. So now when I click the button, it's going to change one of the input variables. So we use this, something like this later to update the 3JS scene. Okay, I think with that understanding now we are moving towards bringing in 3JS. So this is a component that I made earlier. It's the same logic that we saw earlier in the JS fiddle example, but it's been set up within the scope of a single component for Vue.js, which makes the individual component reusable across different scenes, across different places within our application. So it has a few different extra features here and there. So set up the orbit controls and render paths, which helps us process outputs before we actually show it on screen. And on the init method, let me just look back for a second. Okay, so within methods, we have defined the initialize method. And here we do the threejs scene setup. The scene setup is sort of similar to what we had before, but we keep developing and enhancing this so that it looks good as a like a 3D model viewer. Like set up the background so it's light, set up the grid on the ground, and make it in conjunction. At this point, it's not quite that yet. It's just a black background with a yellow sphere in between. But we see how in the mounted method, we call the initialize method and the animate method. That basically starts the threejs scene and it loops, and it still lives as a Vue component. And as an example, like after it's mounted, it's gonna wait for 2 seconds and then call on load model. Actually, this might be an error in the video. Line 87 doesn't need to exist there. I'll try to update that part of the video later.
Yeah, and then we do have these code snippets in the snippet section in the wiki page, right?
Yeah, all of these. In fact, the entire Vue component is available, I think, as a collapsible thing.
Yeah.
So that's super useful for a lot of projects. So with that setup, now when we get npm run dev going, it set up the server for the dev session. And now if we check back, we have the threejs scene interactive and componentized as a Vue component. So I know this section went through a lot real quick, but in the essence of it was trying to set up a threejs scene that works within a Vue component. And we use the different lifecycle hooks in Vue to help us facilitate that. I'd like to pause a few moments here just to, if anyone has questions or discussions before moving on to the next section, where we attach a click event to update we attach to a click event to update the threejs scene.
I see Nambiar has a question right here about threejs component built on backend versus frontend.
Threejs is not really built on the backend. It's a front-end component that we are using entirely. Okay, hopefully everyone's following along. Now we're gonna move to the part where we hook up a click event using Vue to update the threejs scene. So coming back to the threejs component, clearing out more of the content that we had from before. And see the clean page. And within the Vue component, we create a new input. However, this has to be under a div, like Vue components at the template level can contain only one child. So you can't have multiple divs in one Vue component. So soon ahead in this step, I think I'll nest it under one div. But here I'm just setting up the button along with a method to call. So now I create the div, nest all of these inside. And now I go back to the method section where I define the method that's going to be called when anyone clicks that button. Setting up the div so that it always maintains a consistent height with full width. Now in this section, I'll move the part where we were loading the circulars or the sphere, the yellow sphere on after 2 seconds to load when a button is clicked. So now if you press this, it loads the, so that's a way to use one of the input controls to update a threejs scene. Now I think here I'm playing around with different geometry types, and this is just stays as a, to state an example of, it doesn't have to be like a static geometry. You could use threejs in all its possibilities. So here I'm going through a loop to set up a polar array, but just everyone who's familiar with like parametric geometries and things, we could connect certain parameters of the geometry to user inputs, which could be their own input field, and use that to drive our 3D scene. That's not quite fully what we try to address in this workshop. We are going to be loading a model, but just to explore in terms of what the possibilities could be with having a threejs scene connected with form controls or like HTML inputs. Yeah, that's just a simple way to create a circle with some debugging, of course. So going around a circle and putting spheres at those points. I think I go into another part that I'll jump through quick, where it's like a nested loop to create a two-dimensional, like a polar array, where each subsequent geometry is going to be a certain unit distance away. And the main reason in trying to have this example in here is just to make it clear of how we are just updating JavaScript variables, which drive the threejs geometry, and we already got something that's like snazzy and interesting that shows up in a browser environment. I haven't quite connected the parameters which drive that polar array to any sort of input controls, but you could imagine the number of elements in each dimension could be input values for the HTML page. And in the next part, we try to load up a 3D model into the scene. But just want to pause for a quick second if anyone would have anything to discuss. Is threejs rendering constantly when not using controls? Great question. Let me try to recollect.
It can be both, right? You can have it run on a timeout, or on a render cycle, so it's constantly rendering, or there's even ways to do it only on mouse interactions, which decreases the total render cycles, which if you're dealing with really large context, it could be helpful. Although I think GLTF solved a lot of the rendering issues we've seen in Threejs.
Mm-hmm. Yep, so that's a great answer. Essentially, I think it comes down to when this method is called. And was it Josh who just spoke? Mm-hmm. Okay, yeah. So when you have this method set up in the request animation frame, because it calls every frame, that depends on when the browser is gonna call the request animation frame, which doesn't necessarily mean it's gonna be like every refresh cycle, but that's reliant on the browser behavior. However, it could be what Josh just mentioned, where you try to set up your own logic to call this method based on inputs to the controls.
Got it. Thanks.
Sure.
There's also a stats, like Threejs has a stats component that can allow you to track the frame rate, which is helpful if you're trying to debug, if you're having frame rate issues.
You'll find that in a lot of these examples. Just to have a quick look at that stats section. I think this one has a good. It's this small bit on the top left that you see. That's the stats. I hope my computer is able to handle this right now. Yeah, like
I haven't seen this one.
Yeah, this one maxes out on the other laptop that I had, and that I used to keep looking at this, like it used to really suffer. But this is a much better laptop, so I still get 60 FPS on this. And depends on how much you pile up and stack up in your rendering pipeline for the frame rates. A lot of geometry can be difficult. Besides this, Threejs also has a good setup for post-processing effects. So in here, the glowy effect that we see on screen isn't really either part of the geometry. It uses some properties from the materials, but once it renders the scene, the output buffer, which is basically like the 2D array of pixels on here, you could do a lot of effects to those, and those are what Threejs calls post-processing effects. Similar to, I guess, something like Photoshop filters. Maybe that's a bad analogy. I could be wrong about that, but it allows us to set up that pipeline in the flow, and basically you get this glowy, nice effect.
Like Instagram.
Mm-hmm.
Sort of, yeah. I can see the like this might be struggling a bit more video than it's actually struggling on my machine.
Yeah, and then basically how smooth the viewer feels like is basically how much FPS you have, right?
Yeah.
So I was going to share one thing with Vue and Three.js that I found that hopefully no one has to deal with, is that one beautiful part of Vue is the reactivity of it, that like new objects are instantiated and have reactive components, being the two-way data bind.
Mm-hmm.
If you attach Three.js geometries to the Vue instance, now you're attaching geometry that you're telling Vue to be reactive, which can balloon your memory footprint.
Mm-hmm.
Just something to be aware of. You're not going to see that in Angular because it handles the shadow or its version of the shadow DOM differently, but you're going to see that in React as well. So just something that I found that was tripping me up initially.
Yeah, that's really interesting. I'd be curious, like, how come that doesn't happen in Angular? Are you talking about the new Angular?
Yeah, I think when I originally ran into this was like a year or so ago, and it was like Angular, I forgot how they did their numbering, but maybe Angular 8 or 9. But how not every component is by default reactive. And so like things that you attach to this in Vue, especially in Vue 2, if you look at it like in the console, if you like console log your geometry, you'll see every single object and key in your geometry now is reactive.
Oh,
So if you like don't attach it to the Vue instance, you'll see your memory in the console drastically go down. It's because that the reactivity of Vue is great when you're dealing with UI components to do two-way data binding, but when dealing with geometry, you want to keep it away from the Vue instance because you're not really being reactive to it. You're just doing that with three.js outside of Vue, in my opinion.
yeah, that's interesting. I mean, I haven't explored that much into that, but I was thinking like if the threejs object is a object, it would just have been a memory reference, and it would have probably been not reactive when you put it inside data. But it seems like it watches everything that's under that. I get that right?
Yeah, from what I found, if you check out your scene object and open it, you'll see the reactive properties attached to the scene. And of course, when you do scene.add, you're attaching geometry objects to the scene object to be tracked. So you'll see your mesh.object or whatever buffer geometry you attach to it. So you don't really notice it on smaller geometries, but as geometries and contexts get larger, which since we're all dealing with massive context on city scales, or that's what sometimes we strive to, you'll start hitting it at some point.
I think in our examples, we are now storing the scene object into the data field, right?
No.
Yeah, it's just a variable.
Yeah.
So
I've come across other examples on the internet, and I think I was trying to answer this someone. Not really using the data, but using the set get properties as a proxy, and having the geometry and the content itself be a component level variable. It was working out well for a lot of the use cases, but that was interesting. That's something I'm going to check out after this workshop probably. And in terms of FPS, I think the aim people try to shoot is for 60 FPS. But then again, I don't know how, like these days there are newer screens which do faster refresh rates. So I think 90 might be the new benchmark, but don't quote me on that yet. But yeah, I think the current standard like 60 is what you want to get at. Nice. This is gonna be like the last section before I break off for a bit. And like there's some part before lunches that we get through, but in this section we are gonna try to use the component that we have to load a model. So for the beginning example, we start off with a GLTF that's like a more it's supported in, it's like a more web friendly 3D file format, I would say. They have some optimizations in how the file is structured, where like it passes a certain few things directly to the GPU. So that helps you improve load times and improves performances. And following that, we come back to trying to load a 3DM file, which has a few other certain dependencies that we'll get to in time. And quickly before that, some bookkeeping, I guess. Like when creating these experiences for loading models, oftentimes like a reset is like clear the scene and put the new model. You don't want the existing model to be there or two models to be overlapping each other. So we use a single variable and nest any content that's added into the scene under this. So to do that, for in the example where I was having that polar array of spheres, I create a object, a 3.object 3D, which is like a wrapper object in threejs scenes. It has some extra things on it, like you can move the objects together. They have a common transform on them. And I create a new one every time, assign it to a scene content variable that I have at the component level. And right at the beginning, if this scene content is populated, remove that from the scene and then progress to adding new content. So that helps me like keep, I don't have a lot of things in the scene that are floating around that I don't have a reference to, access to. And so in this, how it helps me is like every time I press that button, click me, it's not gonna add a new geometry. It's only gonna, it's first gonna remove the existing one and then add the other one. So if this was like a 10,000 elements array, if I click twice, I have 20,000. But like doing that bookkeeping helps keeps the performance going, and also you don't want overlapping things sometimes, I guess. This section, I'm adding a should be adding a GLTF model. Yeah. So I create a new folder for storing all my models. Label GLTF. Sketchfab is a resource I use not too often, but every now and then. They have a bunch of geometry, a bunch of models that you can use for a whole lot of things. And a lot of them are I think almost all of them are downloadable as GLTF. So if you are following along, you could, I'll post, I don't think I have a link to that, but you could fetch any model from Sketchfab, and for all the ones that they make accessible as downloadable, you could download it as a copy. And this is just for demonstration purposes. Like later when we come back, we are going to be loading Rhino 3DM files, and we have downloadable 3DM files on the example repository. But one thing that's new about the GLTF example here is it has materials and textures associated with it. So the file itself came with the .gltf file, which contains the geometry and properties for the materials, and it has some textures on it, like the trees, the way the wood appears. The information for that is encapsulated in those textures. And just this again is sort of related to the threejs GLTF loader, and also standards for how GLTF files are shared often across, where it's all in one folder at the same level as the .gltf file. And then I have this snippet, which is gonna read the file, and based on this file path that you see on line number 82, it infers the other information that it might need, like the textures and the binary files for the scene. Yeah. GLTF loader is a threejs thing again. So that's one of the great things about they have going. There are a lot of people doing a lot of cool things and building support for a lot of things. GLTF, just for general, it's like this transmission format based on open specification. I think it was started by the Kronos group. I know Blender supports this, tries to support this well, and a lot of game development environment folks use this file format as their way to exchange information, which besides supporting the geometry, materials can also do animations. And threejs would also support that if it's been if it's a part of the scene. So yeah, some people who've been working on this have built this out. We just import it from the threejs scene, and it comes with 3 when you install npm npm i3. And here we import it for our use. And we replaced the part earlier where we had the polar array going with this now, which helped load the threejs or the GLTF model in our threejs scene. And this stood just as an example real quick, because when we built out the Vue application, we use a 3DM file. Okay, maybe we'll come back to that when we do that. And with that, I think we'll reach this checkpoint where you would have a threejs scene as a Vue component that's interactive and able to load load 3DM models in if you check out at this point. And in the next step, we are gonna connect it with the front end framework, which is primarily gonna help make the web page look good, better, presentable, and has a whole bunch of other things that I'll let Hanshen talk about more in detail.
Mayura has a question about whether we can adopt a similar workflow and load 3D models using the backend. Yeah, traditionally, you let's say if you store your model in AWS S3 buckets, then you need your backend to build out a communication with the S3 bucket to pull the models down and inject it into your front-end threejs viewer. In the afternoon session of this class, we'll be using something called Firebase, and the Firebase has their own storage bucket that actually allows you to communicate, upload, and download 3D models directly without relying on a backend. So that's what we'll be covering this afternoon in the workshop. Yeah. Cool. Yeah. So we have 40 minutes left before the end of the morning session. So let's just jump in and then finish the last two steps. Yeah. Yeah. So the UI framework we'll be using for this workshop is something called Vuetify. Let me do a quick introduction about Vuetify. We use Vuetify a lot. It's basically a library that has a lot of pre-built UI components already. So if you just click on, go to vuetify.js.com and then click on Get Started. We can skip the installation part for now and then just look at the UI components. So as you scroll through them, you'll see that, if we click into the button section, they already have a lot of pre-built buttons that we can use, as well as, cards, dialogues, or other form inputs, for example, checkboxes and everything else. And then in order to use Vuetify components, we basically can just go into the source code and then copy out, examples, and then we can modify based on that. So for example, if we want to have a checkbox, then we can just copy this little snippet over. Before we get started, I would invite everyone to go back to the steps in the wiki section, and then just check out the branch here, right here. By checking out this branch, basically, it already complete the installation of Vuetify for you, because sometimes you might run into a lot of issues while setting up Vuetify in Vue. So to get started, let's just jump back into GitHub Desktop, and then in the branches, search for Vuetify setup. Make sure you fetch that, and then let's go back to our console. I'll exit this out, and then in the same folder you can run npm install to install the Vuetify required packages needed. And then I want to mention one thing. So for the previous steps, we have a lot of recorded videos to cover those, because sometimes we end up spending a lot of time setting up things. So I would feel like having the record video would be the best approach to do this. However, for the rest of the workshop, it'll be more of a hands-on step-by-step approach. That will be, building out these things more like by typing it directly rather than, watching recorded videos. So the format might be a little bit different. So now we just finished installing all the required packages necessary for Vuetify. We can say npm run dev to get it started. Okay, cool. So I finished building, and let's jump back to your localhost 8081. So you'll see, a very similar window that we had before as the last step. However, on top of it, you see a header bar with a button. If you dive into the source code and then go to this component called setNav.view, let me explain a little bit of how the page is set up currently. So app.view is basically the single page web app that we're looking at over here. And then inside of app.view, we currently have two components referenced. The setNav component is basically this header bar on the top that contains this button. And the dashboard contains the threejs viewer as well as this user login status. If we jump to let's see, if we jump to 3W really quick, or maybe the dashboard. For example, let's build in something that we can control the settings of the threejs scene. So first of all, I'm going to add a checkbox to the scene. So I'll just copy this one over and then paste it into Visual Studio Code. And then if we jump back to the page, because of hot reloading, we already see this checkbox in the scene, and then we can check it out by clicking on it. It's running. And then I'm going to change the label a little bit so that we can customize this checkbox for controlling grid visibility. And then I'm also going to change the label a little bit. And then over here, you see remodel is currently this checkbox is tying to a variable called ex4. Let's just change it to display grid setting. Display grid. And then we'll also add the same variable down here. So and by default, we give it a false value. I think there's a question in the chat. No. Oh, okay. That's good. Okay. Cool. And let's just test and see if our variable is working. So I can say save it. Let's go and reference some snippets from the code. So let's go to wiki snippets. Over here, I already have a section for the UIs to control the threejs scene. Let's see. Yeah, let's first of all implement some settings into the threejs scene. So let's, for example, add a grid in there. Over here, we have something called update grid visibility, and also the zoom out button. So copy this, and then we go to the 3W, which contains our threejs viewer. And then let's just add it to the end of the method. So basically, what the function does is once we click onto a button, we are calling to this function, and then what it does is zoom extend to all the geometries inside of our scene. And you see here, it's complaining about missing a variable. So over here at the top, very top, I'll uncomment this line to create this scene content. And then since scene content is being populated every time we add in a geometry. Is that correct?
Yes, whenever the geometry is updated.
Mm-hmm. Yeah. Cool. And then let's jump back here. So the next step will be actually hooking up the buttons and then to do the zoom extend for this geometry. So let's go back to Vuetify and then find the buttons for us to use. So let's just go and retrieve a generic button, maybe something under the depressed type. I'll copy over one of these buttons here, and then paste it over to the threejs scene. What did it come? Ah,
Undo.
put it inside this div.
Maybe a new div. Sorry.
I'll just add this button in to test for now.
Yeah.
And then once you go back to our page, you should see. Let's refresh. Actually, let me move the buttons out to the dashboard. Maybe it'll be better. So if we move it out to here, save it. Let's see. Yeah, so now you see we have the normal buttons here. Right now, when we click on the button, it actually doesn't do anything because we haven't hooked it up with any other functions that we're going to use yet. So let's just go ahead and do that. So first of all, I'm going to go back to the dashboard.view and actually create a dummy method. So I'll say button click. And then for now, we can just console log something. Message received. Save it. And then this function right now is not being consumed by anything. So we'll go back to our Beautify buttons. And over here, hook up the click event. Paste it. And save. And now if we open our front-end console, I'll get rid of that really quick. And then if we refresh that, those errors should be disappearing. Okay, that's good. And then now if we click on the buttons, we should see message received. So at this point, the button is actually hooked up to some of the methods in the same dashboard.view file. And next thing we're going to do, if we dive back to dashboard.view, we'll see that the components, the three components that actually contains the viewer is, in a way, a children of the dashboard.view component. In order to call into methods inside that component, we need to use something called ref. I think syntax is you can ref and then can call it, the three viewer, save it. And then now instead of just saying message.receive, we can say this dot ref and then dot three viewer. Did I spell it right? Sui viewer. And then from there, we can decide which function we want to call. So let's jump back to the Sui.view really quick. And then let's hook up the Zoom function that we copy and pasted from the snippets. So if we copy this name and paste it over here, and then I'm just going to do a quick console log over here just to make sure that we got this running. Starting to Zoom. And click save. Now we should see both console messages. Let's try it out. Can I read the property of undefined reading Sui.view? Let's see. So we have the ref set up here, Sui viewer. And then we do, I have double dollars in here. Let's see. And then I will click on it. You see that first we received a console log from the dashboard.view, which is called the message receipt. And then we also got the message called starting to Zoom, and then that's from that's inside of our Sui.view file. So let's see if it's working now by zooming out a little bit and then click on this button. It seems like the functions are being called, but nothing is working. It's probably because our scene objects right now is not referencing the sphere geometry. So let's go back to Sui.view really quick and then see how we are constructing and adding the geometry into the scene right now. Amit?
Yeah.
Right now, are you just adding the geometry directly in the init function?
Yeah.
Okay.
That got.
So geometry, threejs. Okay, so I'll also say that over here, I'll call scene content. I think it's an array.
I think you can just set the value to sphere for now.
Okay. The reason why I want to set the scene content as sphere because in the zoom, in the on button click zoom out function, it's trying to basically zoom to all the geometries inside the scene content. The reason why it wasn't working when we pressed the button earlier is that it's trying to zoom to some geometry, but the variable is null. There's no geometry in it. That's why it didn't zoom. So now if we come back here, zoom out a little bit, and then click on the button, see now the function is working. So this covers the step of hooking up a simple Vuetify button and then actually connecting it to some functions inside the threejs scene. And then if we go back to steps, let's check out the branch inside the threejs viewer settings branch. That basically has a lot more viewer settings built out using the similar Vuetify components. So if we jump back to the GitHub desktop, and then let's go to, what is this thing called? Workshop viewer settings. And then for now, I'll just discard all my changes locally because this branch already contains most of this UI elements we need. And make sure that our developed server's Webpack is running and compiling properly. Now, if we refresh the page, it's already refreshed. So you see here, down here, we have the zoom button in a better graphic, and also a slider that controls the zoom levels, and as well as a checkbox for grid. So when you uncheck this, basically it controls the grid visibility or not. Yeah. So that pretty much covers the steps for for setting up threejs viewer settings. Let me explain, since we still have 20 minutes, I'll explain a little bit of how the buttons are hooked up and then which functions they're calling. So I already explained the zoom extend buttons right here. Let's dive into the checkbox for grid. The checkboxes are located inside the dashboard.view file inside here, we see the view checkbox, and then it's being labeled as grid, right? And then every time the value changes, this at unchanged event gets called, and then Vue knows to call this function called update grid visibility. So if we do a simple search and go to that function, it's inside the same dashboard.vue file, where it's calling a similar syntax where it's referencing the three viewer through refs. And then inside the three viewer, we actually have a function called set grid visibility. If you just do a simple search, you'll notice that this function is actually not being stored inside the dashboard.vue. It's being stored inside the suite.vue file if you look into it. Do a similar search, we'll find out that set grid visibility basically takes in a value. In this case, I assume it's a Boolean value, true or false, and then basically it first assign this new Boolean variable to our existing variable called grid visibility, and then I call in a subsequent function called update grid visibility, which it first check if we have a ground grid setup already, which if you look into the scene, we do. And then if we do have a ground grid, then we remove it. Otherwise, if the grid visibility is true, then we add the grid back in there. So that's basically how the checkbox is controlling the function calls into the viewer. Yeah. I think that pretty much concludes the steps for the threejs viewer settings setup. Is there any questions about any of the steps we mentioned in the morning session? Once we get back in for the afternoon session at 2 p.m., we will talk about so far we have seen how to load the GLTF file into the scene, but in the afternoon session we'll show how you can upload how you can reference first a local 3D model into the viewer, and then we'll talk about how you set up Firebase for authentication, storage, and database, and then we'll be uploading a random model to the Firebase storage and pull it down and to load it into the viewer. And then if we have time, we'll also introduce a little bit of managing the access control to your model. So in case if you want to share it or make it public, you can do so. If you want to keep your model private, not everyone have access to your models. Yeah. Okay. Does the browser cache different instances of Zoom?
Yeah. Well, caching is on the browser is a deep topic. In this reference, we could cache the if we wanted to. However, we do not do it, and in the setup that we've seen so far, it would be like not really useful because whenever the threejs scene render is called, it looks at the attributes of the scale property of each of those threejs geometry objects, and when we update the scale, it has to re-render that anyway. So even if we were to load it from the cache, because it's still gonna go through the same render pipeline, the caching would only add more time to the process and would most probably lead to like a less optimal performance than if we were to not use it. And main reason being, we update the scale at a very high level, which is basically gonna, like, it affects the matrix representation of all of its children. So it would re-render it anyways. Hope that answers your question, or feel free to shout back if anything was not clear. Awesome.
Yeah, while we're waiting for questions, I'll just paste the afternoon link in the chat as well. There's a question about does it work on mobile? So in the afternoon section, let me go through the steps really quick again. At the very end, we'll talk about how you can deploy and then use Firebase hosting to host your threejs web viewer. And then once it's being hosted, then basically you can access the same URL on your mobile phone, and then you should be able to load models into the viewer. You probably won't be able to upload any 3D models locally from your mobile, but loading should work.
Yeah.
Yeah.
And like, I think we've primarily done the workshop thinking of it as a web viewer. Almost all of it should translate smoothly into a mobile experience, but we haven't tried to make the UI consideration. I think that's one of the main critical features beyond when representing something as a mobile app. So technically, yes. Experience-wise, your mileage might vary.
Yeah. So one quick way to test is to copy this demo link and then just put it on your phone browser and see if you have access to that, and then see if you can actually load up models and see if it's working or not. And in the meantime, I'm pasting the link information for the afternoon session in the chat. But you also have this information in the email I sent out yesterday evening as well.
I think one of the questions I saw in the chat was how to integrate a web viewer in, like, I'm guessing Rhino and or Revit, like as an embedded viewer.
Oh, so you mean like a Rhino plugin or something which has a web viewer running inside?
Yeah, that's what I assume was the
Yeah.
I just saw that one. I thought it was interesting to bring up.
Yeah.
Yeah, I think
That's a good one.
you mentioned Blazor, right? And then there's other people who mentioned C# and WebView or something like that.
Yeah, I'm curious of the trade-offs between those solutions, if there is any that are noticeable.
Yeah, personally, like, I know that people still use C# before, but I haven't touched it personally. But from what I heard, and then same thing as I wrote in the chat, I heard that the library itself is like 70, 80 megabytes. So that's pretty, that's a large size. Like sometimes it's hard for deployment. And then from my understanding for C#, you're basically just embedding like a web-based viewer inside of the .NET libraries.
Like a browser engine that runs inside.
Yeah.
Yeah. No, maybe. I'm not too experienced with that side of things. But I've heard about C# being discussed around in a couple of forums. That's been the one that's been like the most prominent in my awareness. But even if anyone else around on this call has more experience, like, would be nice to share.
I'm trying to find out if, see, the Haikyubo project.
Yeah, that was
It's
the one
the
this
one-
summer.
Yeah, it was using Blazor with JavaScript.
Oh yeah.
Yeah.
I was following this for a little bit. And I think the way they got things to do was like they were embedding JavaScript strings, which was coded in C#.
Yeah.
And executing on inside the engine.
Yes.
Was pretty hacky.
Let's see if we can find any snippets. Yeah, there's the core, there's the web. Yeah, I think if for anyone who is interested, maybe just check out this repo. I was a part of the project, but don't remember much. I'll wait for 1 more minute.
Sure. Yeah. So like we are trying to be really sharp on the time because we got a lot of things lined up and we want to make sure we finish by the end of the day.
That's great to hear, Mustafa.
Oh yeah, that's really reassuring.
And then just a quick thing to mention, for the first step in the afternoon session, as you see here, we'll be going over how to load a 3D model, a 3DM model, like a random model into the viewer. And then the rest of the workshop will revolve basically by uploading and downloading random models into the web app. So I'll be only using the 3DM format, basically.
Yeah, like the example earlier was GLTF, but that was just the quick and easy way for anyone who doesn't have a 3DM file to view it on both sides.
Yeah.
But
I think Construe is based on threejs, right?
yeah,
Construe
is based on an old.
Spectacles, which is based on threejs.
Yep.
Yeah. Yeah, Core Studio has a library called Spectacles, which is built on top of threejs that we consume for both Mirror and Construe. Yeah, so it is based on threejs.
One thing about threejs is they keep changing their code base rather quickly, and there's not a lot of emphasis on trying to maintain backward compatibility. So I think like even if you use different versions of threejs, there are parts that would either need to be reworked or like some issues. So that's one complaint I've read across a lot of places on forums and stuff about threejs. The version number that you use is rather more important than one would normally assume.
Cool, then let's jump in for the first step in the afternoon session. If you want to follow along, feel free to check out the workshop viewer setting branch. We'll be starting from that branch. So let me go to GitHub desktop first, and then make sure that I'm on the same branch. And then also open up the snippet. We have some code snippets for showing how you import the 3DM loader from the threejs right here. The first thing first, open up 3.vue. Scroll up to where we're previously importing libraries from modules from threejs, and then I'll make sure to import the 3DM loader right underneath there. So I'll copy over this line and then paste it right here. So that should give us 3DM loader. And then right now it's complaining that it's being imported but never used, but it's okay, we'll be using it right afterwards. And then I'll copy these snippets and put it into the same file as well. Previously, I noticed that we are just importing geometry directly inside of the initialize method. So what I think would be nice is to actually create a new function separately that we can call into for loading random geometries. So what I would do is create a new function called load 3DM at the very end of all the other functions. And then for now, I'll just copy in the snippets. And basically what it do is it creates a container for all the same objects. It calls into the 3DM loader and initialize it. I think in order for the 3DM loader to run, it needs a reference to the Rhino 3DM JavaScript library, and that's what it's doing on line 150. And then right afterwards, you see here, we call the Rhino 3DM loader, the load method, and then you can simply put in a path to your random model there. And then as the first step, I'm going to first upload, a local model to test. But before that, let's see what's going on. Am I missing a bracket somewhere?
Parentheses.
Okay, I think it's good now. Okay, let's embed let's copy over a random model and put it into the public folder now. And then I'll just create a new folder called models. And inside there, I'll just put all the random files there. If you go to our GitHub main page, go to code, and then inside of README, we have 2 random models provided. I'll just download this cubic looking one first. Save, and then copy it and put it into the folder. Now you see it's added to our project hierarchy now. And then what we can do once we have the model added is to reference it inside of this string. What we can do is we can call models dot model that should work. Let's give it a try.
We need a slash.
This one.
Models slash model.
And let's see. So if we go back to our localhost page, localhost 8081. And then let's open up our console. First thing first, there's no error in the console, which is great. But one thing we didn't do yet is we created this new method called load3dm, but we're not calling it anywhere yet. So what I will do is I'll copy this method name, and then I'll add it to the end of the initialize, so that every time the page loads, at the very end, I'll try to load up our local random model. So I'll call this method by saying this dot load3dm, and that should be able to load up our models. Let's see. I see there are some scale issues, but you do see, the model being loaded here. Right now it's pretty messy here, so I'll just clean up our old geometry and make sure that we only have the random geometry being presented in the scene. So I'll go back and clean up some of these things. So basically just getting rid of these codes that generate the sphere geometry. And then now if we jump back to localhost, you see the model is loaded, and you can use the zoom extend button to zoom it to the correct scale. And then let's dive back and then just explain a little bit what's going on in the load3dm method. So as I mentioned, after we set the random 3dm library path, basically over here we just pass it, give it a local directory or a URL for the 3dm loader to load the geometry. And once it finishes parsing the random model and then spits out all the elements, over here the model basically contains a list of converted threejs mesh elements that we can add it to the scene. So over here on line 56, we're basically dumping all of them into the same objects. You might notice that there's one line on line 157 where we're setting the rotation. Maybe I can make this a little bit bigger. So you see here, we are setting out the x rotation with a negative pi divided by 2. The reason why we're doing this is because, as you probably all of you know, right now z-axis is pointing up, right? But then I think threejs have the y as the top. That's why we need to add this line. Otherwise, without this line, our model will be oriented sideways instead. Let's see. Yeah.
I'll say one thing quick.
Yeah.
Like threejs has a way internally to reorient the directions of the XYZ, but we have not used that over here just to keep it compatible with a lot of the other things that we have going, our scripts. But yeah, so
that's another option that you might have if you are sure that you're exclusively only ever loading Rhino models.
Yeah, that's great. And then let's jump back to the steps really quick. So what we have covered so far is we added a local 3D model. We also had the 3DM loader reference and setup. We're also able to import geometries from a local 3D model. So that completes the step for loading the 3DM model into the viewer. If you wasn't able to follow the steps, you can check out this branch directly. Is there any questions? Okay, I see. I don't have Rhino on this machine, so I can't open the file. Are those mesh boxes? Can you say a quick word about layers, nerves, colors? Yes, so the 3DM loader is actually pretty great. So even the model that we attach is a mesh model, but even if you have something that has points, curves, B-reps, I'll be able to convert them into corresponding threejs elements and add it to the scene. In fact, if you go to, let me see, if you go to the demo link, and let me just log in really quick. Oh wait, we'll be logging into your models.
Yeah.
Well, give me 1 second.
Yeah.
So, and we're doing some stuff behind the scene, but I'm basically just going to make one of the models that I have available to the public. Change this to true. Okay. Now if we refresh this and go to load existing models, we'll see a new model called LGA Sculpture. It's a pretty messy random model. Basically, it's one of the projects that our colleague is working on right now. But then you'll see it has a lot of different geometry types in there. So you see it's loaded. You're able to load in some grid lines and some, I'm not sure if you can load annotations, but you see lines. There is some B-rep geometries for the slabs, and then there is also some points being converted and imported into the scene as well. So I would say that, you know, the 3DM loader is pretty capable of doing these things. In terms of layers and colors, I haven't really tested that much, but we can take a look by just console logging the geometry that we imported really quick. So let's see. So if we jump back to load 3DM, you know, at this point we already have the, I think we probably won't get much information from these models. Let's just take a look. Yeah, so the models we get here is already a converted threejs elements. Use your data. So you see we do have some layers. In this case, it's a default layer, and it has the layer. See, has plot colors, visible, and then object type, warnings, use your data. I'm not sure if you can get color from here. But yeah, you do get the layer information, at least on a pretty basic level. You get the layer color, but I don't know if you can get the geometry color from here.
No. One quick I can add to that, like more in general, I guess. So the Rhino 3DM threejs loader, that's actually a subset of, or like it uses Rhino 3DM.js somewhere behind the scenes to load the model. And that's Rhino 3DM.js. That's another interesting project that the team from McNeil maintains. It's a WebAssembly based package to load the types that you might be familiar with that come from the Rhino world. And that can give you information about the 3DM file, like it knows how to read it. But I think the whole project is, I'm not fully sure of the completeness of the full feature set of it. And it also lets you do some CAD operations, like constructive solid geometry operations, like booleans and create lines and knobs.
but I am not. I can't recollect like the completeness of it.
Yeah, I've seen you using the Rhino 3DM library. You can get like user dictionary information out. You can also get some attributes out, but in terms of other things, I'm not too certain.
Yeah.
Colors, I'm not too sure. Can we model using this library, e.g. drop basic groups? I think so. Yeah, we can. For example, we can use Rhino 3DM to construct Rhino lines, and then we can convert those into threejs corresponding like Bezier curves, and then you can add it to the scene and it should display.
Yeah.
Yeah.
And one quick thing, like when we are working with threejs, doesn't necessarily have to be constrained to Rhino things. Like there's this other thing that you could use to create like knobs based geometry, which isn't, it might differ a bit from like Rhino things, but this is working with threejs and another library trying to work with like the knobs geometry concept. But yeah.
Cool.
I think there's another question.
Do we have another question? What are the things Rhino Compute does which Rhino 3DM.js cannot do? I haven't really used that much Rhino Compute personally, but one thing I can tell you is like for a lot of geometry and manipulation, for example, like for the Boolean doing Boolean union or Boolean operations on two geometries, you cannot you can't really do that with the Rhino 3DM JavaScript library because that's a pretty lightweight library that basically allows you to construct some simple geometries. However, I think you can do that using Rhino Compute, right? You can also use Rhino Compute to run some Grasshopper script, I think.
Yeah, I think Rhino Compute is like their whole engine. You can, I'm not sure where all you can run it. I don't know if you can run it in the browser.
You can run it in the server, but I don't think you can run it in the browser.
Yeah, right. Yeah, that's what I thought.
Yeah. Cool.
There's another one over
There's
there.
another one.
Oh, good to see how to explore this more in depth. I assume by this you mean the Rhino 3DM loader.
If you are talking about the loader, yeah, I think Louis, who works with McNeil, created this 3DM loader for 3js, 3DM loader 3js, and then he has a lot of documentations online, so that's what you can look into. Yeah, so yeah. Here you can see some of the supported geometry types. So for example, like everything on the left-hand side is all the geometry types from 3DM, and then they'll be able to convert it into 3js. And here's some other code examples you can check out. And other methods. Yeah, so if you take a look at this link, you should get pretty good information from there.
Yeah, I think like that could be a full thing. That would be worth exploring with like the whole WebAssembly way of how they do it. It's actually pretty interesting.
Yeah.
But we don't want to digress from the course right now with like trying to get the whole workshop targets done. But would be happy to catch up anytime post workshop, or feel free to contact us.
Yeah. Okay. With that, let's move on to the next step. So the rest of the workshop will be very Firebase heavy. So let me explain in a broader level what Firebase is. Where is our diagram? I think it's in the wiki page, the first. So if you go to home wiki, if you scroll down a little bit, Firebase is a Google product that has a lot of different services. So if you just search Firebase in Google, yeah, just go to firebase.google. And then you can automatically log in if you already have a Google account. That's why we kind of specify that it's one of the requirements for the workshop. And then you can click on, say, go to console. And then let's just start with a brand new project from scratch. So I'll say workshop demo. Cool. That's fine.
You all might want to use a different name because that turns into a URL at some point, and that's better to be unique for all the participants if you're following along.
Yeah, we would encourage you to create your own project and follow along. I think that would be the best way. And then if we click continue, we can either include Google Analytics or not. For now, I'll just disable it and create a project. Normally, I think this process probably take like 30 seconds or so. It's not very long. And then in the meantime, while we're waiting for the project to be created, I want to talk about the 3 main things we're gonna be using from Firebase. So if you go to home in the wiki page, basically this morning we set up a node server backend with a Vue frontend. However, for the rest of the workshop, we won't really need the node server that much. We mainly want to introduce node server just in case, if later down the road you want to build something based off this, but call into other services or REST APIs, you can do that through our node server. But then the good thing about Firebase is that most of their products, like the authentication, the cloud storage, or the databases, can be consumed directly from front end. So that's something that we find very interesting, and then we love that feature. And let's just jump back to this really quick. Okay, so it's just finishing, which is great. And so once we go into it, this will be our blank project. To get started, we can go to authentication and say get started. And then over here, you basically can pick and choose, which of login functionality you want to include in your project. For the demo, we only allowed Google sign-ins, so that's what I'll be showing over here. So first thing, make sure you click into Google, and then make sure you click on this little switch to enable it. And I think in order for things to work out, you have to choose a support email. And then you can just say save. And once this finished saving, basically configure this current Firebase project to allow all the Google logins. So you don't have to ask your sign up to sign up a new account using email and password. They can simply use their existing Google accounts to do that. We'll also initialize our database really quick while we're at it. Just say go to Firestore database and say create database. And then for now, let's just make sure that we all start in production mode. And then you can choose whatever the region that's closer to you. And then overall, if we go back to the diagram we had earlier, basically we'll ask the user to send credentials to authentication, and then Firebase will return an authenticated user to us, which will store in memory. And then we'll leverage the storage platform of Firebase to upload models, in this case random models, and download them later down the road. And for the database part, we're mainly just storing some information about the model that we upload. For example, model name, the URL to the storage location that corresponding to this model, and then what time it was uploaded, and whether it's public, and then some information about the author itself. Okay, so now we have the Firestore configured. We'll leave it as it is for now, and then just move on to configure the last thing, the storage. Oh, okay, so it's already automatically configured, which is pretty good. You can use it, just by directly upload a file if you want to, but we'll show you, how you can configure this in the Vue.js environment.
There's a question up there about, can we talk about marketplace like Sketchfab for 3D models work with WASM and resources?
I see like those are two entirely different things without necessarily a lot of resources. Sketchfab, they have a feature where like they convert all the models you upload into GLTF, but it could be any other format. And WASM is more like a means to get the browser to understand non-JavaScript code. The I don't.
That's WebAssembly, right? WASM.
Yeah.
Yeah. Yeah. But the WebAssembly is basically how you can convert like libraries you wrote in other languages and then consume them in a browser environment.
Yeah.
Yeah. But you can certainly, use the technology we show in this workshop to build up something similar to Sketchfab. For example, you can like once a user upload a model, you can detect which file it is, and then you can import corresponding, for example, threejs loaders to those files, and then just convert all of them into a threejs elements if you want to. You can also configure some backend services that handles the model conversion so that you can always have the same kind of format coming in from the backend.
Yeah, I see. Like I was just trying to understand like how would the architecture of such web apps look like if you have a marketplace for like 3D models? Do you create like one upload component which talks to backend and then other like view components which are like JPEG or GIF of other models on the database, and it's just view, and when you click it, it directs to the viewer?
Yeah, I think if we jump back to the diagram really quick, home, yeah. So if you want to build a marketplace for different models, I think you can use, let's say, the database to store different model informations, right? And then once you log onto your page, you can pull all the model info from the database and display them as individual cards that kind of give you, the kind of marketplace look. And then let's say once a user click into one of these cards, then we can pull the model URL from the cards that they clicked, and then use the URL to pull the model that's stored on the storage bucket back into our front-end Vue app. That would be, how you create kind of model marketplace using Firebase. However, if you want to use something like, let's say, a MongoDB with, AWS S3 storage, then you would need to configure that through the node server, which, one of them calls into MongoDB to retrieve a list of models that has been uploaded. And then also, you have to communicate with AWS S3 to pull that model down in order for it to be loaded into the viewer.
Yeah, I mean,
Got it.
yeah, I guess specifically talking about Sketchfab sort of thing, like the scale that might be involved with trying to handle would influence a lot of the decisions about all of these and the general architecture, and I'm sure that will easily go into like months, if not years long projects.
And then the structure really depends on which technology and which product you're consuming. Yeah. So in summary, like if you use Firebase, then you don't necessarily need a backend node server to handle these things. However, if you use other products, then you probably need a backend server to do so.
Got it. And I don't want to distract the content, but can I ask like one clarifying question about WASM?
Sure.
Yeah. So does the whole WASM workflow would be like .NET based web app, or like totally without JavaScript? And I'm trying to understand, like we are doing operating geometry on like natively on like C# or C language, right?
Yeah. So maybe I'll share a quick few things that I know about WASM, and like it's not super important in terms of the scope of this, but like WASM is they call it, I think, the intermediate compiler language. It's basically like when we compile .NET or C# or something, it compiles for a specific architecture that runs on the infrastructure that it's meant to run on. Could be like Windows, Linux, and the different bit system, the addressing systems. But when it's a WebAssembly thing, the compile code is targeted to this other intermediate format that I'm forgetting the name of, which can run in the browser. So that completely happens on like setting up libraries. I think there is support for C. I think .NET, Rust, I think has a good support for compiling to WebAssembly. So it becomes the compilation target for like when you're building logic that's in some language. What is, and so like that's the scope of WASM and what they're trying to build with WASM. And WASM is just a WebAssembly language or something like that. That's the file format, I think, or the extension.
Awesome.
That
Thank you. Yeah, I know like Hyper uses it, so I was just curious.
I think I think I heard something about that, but yeah, they say something about that on Twitter, but I forgot what it is. Yeah, okay. So let's jump back to the steps about connecting to a Firebase setup. So now we have configured our Firebase project and then initialize, the database and authentication. The next thing we need to do is we need to install the Firebase npm packages that we need to use in order to call into those services. One thing I want to mention really quick is that Firebase is, they're still developing it and it's evolving quite rapidly. So when we are setting these things up, we're using a Firebase version 8 and another package called Firebase UI version 5. But now I think both of them has a newer version like V9 for Firebase and V6 for the UI libraries. So just so you're aware. And then that's why when we are doing npm install, we want to specify the version for both of the libraries. So let me stop my local server really quick and then just say npm install Firebase 8.10.0 and then Firebase UI 5.0.0. And then Firebase library contains basically all the references you need to call into the database, the storage, and the auth. However, Firebase UI, I think currently it mainly just have some pre-built UI modules for authentication. And then you don't have to use the UI library in conjunction with the Firebase libraries. You can, if you want to build out your own UIs, you can totally like disregard the UI library yourself if you want to. Okay, so we finished installing it, and then let's just quickly do a npm run dep. Okay, so it's finished building, and then let's just do a quick test. Yeah, and everything else is still working. That's great. So if we jump back to the steps, the next step will be actually adding in all of the Firebase references from the packages that we just downloaded. So I'll go back to my project, and then first of all, I'm going to create a new file called Firebase.js. So import all the references to those libraries. Here. And then I'll go to snippets, and then go to the Firebase. Wait, let me refresh. Yeah, Firebase.js right here. So copy this entire file, and then paste it into the Firebase.js file that you just created. And then let me explain what's happening right here. So we're importing the app, storage, and Firestore. These are the services we'll be using from the Firebase packages. We're also referencing in the UI libraries that we just installed. We're also importing some CSS files so that our UI elements for authentication will look correct. Over here, you will see that we comment out these configuration secrets down here. I'm going to show you where you can get these informations from your own Firebase project. So if you go back to the project you just created, go to project overview, and then go to project settings from this little gear button. And then from there, if you, where it should be,
I think it should be from the web integration link.
I think that embed button has the values we need.
Where?
That embed.
Oh yeah, yes. Sorry, I forgot. So if you click on, so first of all, you have to set up your Firebase project for the web, because Firebase is also catering a lot to mobile development for iOS and Android, or Unity if you want to. But in this case, we're doing it for web app. So let's click on this little icon, the simplest web, and then you actually need to register a web app. So I'll just say workshop demo app. And then while I'm at it, I also set up Firebase hosting. And then, yeah, so previously we already installed this Firebase modules, and then we're doing similar things in the Firebase.js file. And then we can just click next. And then I think at this point, we can also install the Firebase CLI while we're at it. So let's just copy these and then paste it in here. This is going to install the Firebase command line tools that we'll need later on when we're deploying our local repo to the host to Firebase hosting.
Sorry, while we're waiting, this is a small tangent, but Firebase also has a really great Unity integration for storing assets on their database and kind of calling them from a Unity application.
Mm-hmm.
Yeah, I personally haven't tried it out, but I would imagine it would be pretty useful. Have you guys used it? Like, have you guys have any Unity projects that's already doing this?
I've used their hosting services for it and for storage as well, yes.
If you use the hosting services for Unity, does it mean that you can essentially have a web-hosted gaming environment?
A WebGL build, yes.
Okay, I see. That's cool. We should look into it. Okay, so we just finished installing the Firebase tools, CLI tools, and then let's just go back and run npm run dev. Yeah, and then we'll do these things. We'll copy these steps and do it later. Just, later. Go to console. And then now after we configure our app, you see we have this new section called your apps. If you scroll down a little bit, you can get your project configuration here. So you can simply just click on this copy button and then put it right over here. Without these project configuration information, you won't be able to use your Firebase product locally. And then after we paste in the configuration secrets, we basically just need to call initialize app with our configuration to make sure the app is running. Then we want to reference, our database references, our authentication references, as well as the UI we'll be using for logging in, as well as storage. We're exporting them as these 4 variables, and then for this setup, we already have a Vue store set up already, so we'll be referencing these things into the Vue store, so we can consume these libraries from all the individual front pages or components. So let's dive into Vue store really quick. Over here, we have a pretty simple setup. I know we kind of skipped this process to set up Vue store, but on a broader level, Vue store basically just give you ability to store global variables and have functions to retrieve or set those global variables as well. So if you take a look right now, we have a variable called users. We also have a mutation function called set user profile. And then if we do a global search, we actually see that our setNav.vue has some function for toggling this information. We can test this out really quickly. If we go to localhost, yeah, let me do some. Maybe I didn't set it up. Should work, but okay, let's just skip that for now. So in the Vue store, now that we have all the Firebase reference ready, we should import them into this. So first thing first, I'm going to name a new variable called db, and then also import fb from Firebase. And then over here, fb.d. We also need our UI for logging in, so it'll be fb.ui and storage.b. I think there's one last, so let me check. db auth, okay. Okay, once we have these things set up, we can try to consume them on the setNav.vue, basically hooking up the login buttons to actually display something that we can ask user to use their Google account to sign in. I know why it's not working right now because we haven't hooked this up yet. So if we just so what's happening right now is that our login button is not actually calling this toggle login functions that we wanted to consume. So we just hook up really quick and make sure it's working first before we actually set up the Firebase connections. And then let's go back and test really quick. Can I read property of this? Let me see how it's set up in the snippets. Wait, let me see. Always forgetting some syntax.
Yeah.
Now it should work. Okay, cool. So now if you click on this, you see that every time you click on it, it's toggling between a true Boolean true false values, and then these variables actually being stored in the Vue store as a global variable as well. Is there any questions in the chat?
Yeah.
Okay. Okay, sounds good. And now we're going to hook up the Firebase login functions to the actual login buttons over here. And in order to do that, first thing first, we're going to import our auth, our UI, and then as well as Firebase. And then I forgot to set this up. Okay. And then let's go back here, go to setnav.view. And then for a quick test, let's go to snippet really quick. If you go to snippets, there's a section that details how you initialize a Firebase UI. So let's just copy this snippet really quick, and then I'll put it actually inside of multifunction. And then over here, you see it's missing a reference to Firebase UI, but since we already configured it in the store, we can simply do this.ui. And then for Firebase.auth, we can replace it with this.auth. And what is it complaining? Oh, it's not being used yet. That's fine. And then let's go to the next step in the snippet. Yeah. So in order, yeah, let's go here first. So once we have the UI initialized, we're going to run it by calling UI.start. It's going to try to look for HTML tag with the ID of Firebase UI auth container. What it's going to do is, for example, you see here logging options, we allow a user to do OAuth with Google, Facebook, Twitter, and GitHub. For this, since we already only configure it for Google, we only have Google in this case. And then we're also going to add up this HTML container that has the same ID over here. So go back to snippets, actually copy out this section tag with the correct ID. And then I'll just put it anywhere inside of our setnet.view file. And then one thing left is you see here it's still missing a Firebase references. So what we're going to do is just saying this.auth. And that should work. Let's give it a try. Probably not. So it's complaining about missing auth UI. Let's see where it is. This.ui.auth. Maybe I should just say this.auth. We already have the UI ready in the Firebase setup. So over here, we have the auth UI and the auth. I think on Firebase, we already have this set up as UI. So we can jump back here, get rid of this line entirely, since we already have it set running, and just say this.ui start, and that should work. Okay, so a different error, which is good. So over here, undefined provider ID. Let's see. So in this case, this the auth Google provide. So it's saying that auth doesn't have Google. What if we do Firebase stop? Let's see. Okay, I think it's running. That's good, but I think maybe it's being covered by. Comment this real quick. Yeah, so you see here, I think it's being hidden. It's being covered by the threejs thing. So I just comment it for now, and we can test out this login with Google button. So what's going on is, if you take a look at this, it's basically we have this container called Firebase auth container, and then when we call into, when we call this.ui.start, it's basically, it points to the container and then it just renders whatever the providers you provided with it. So if you add a GitHub auth provider with a corresponding ID, then it'll just show up as a different option as well. We can test that really quick. So if we just copy these things, even though we haven't had it configured on our own account, should be able to at least see the buttons. Let's see. Yeah, so you see here, as we're adding in different options, it'll just automatically populates these options. And that's basically what the Firebase UI library handles. And then let's just try logging in with Google. So as you see with many other products that already have this Google Auth configured, you just simply have to click into the account and then it should handle the login. I think that's fine. And then, so we're logged in, but then our Vue app is actually, okay, let's see. What kind of auth would you allow access only for folks in one's company? Yeah, we can take a look at that really quick. So if you go to auth, log sign in method, right? Since right now we only have Google, but if you go to add new provider, I think all of the TT members, or like Thornton Tomasetti use Microsoft's, yeah, so you can configure that for your company. Another thing you can do is, let's see if you can see any users here. So you see here, I recently just logged in using my account. Now I have this user listed. So if there's other people using the same sign in button, you have their account information as well. If you want to configure access only for folks in your company, I think you can probably set up some rules to do that. But if you don't want to just do it simply, you can, like, if there's anybody you don't want them to get access to, you can also just disable their account simply in this dashboard really quick. One of the reasons why I really like using Firebase is just how simple the entire, that dashboard is easy to control. And then let's jump back really quick to our local hosted page. So over here, we sign in. Normally, I'll ask you for a redirect URL. Gotcha. What if there's bots creating new accounts? How do you stop that? That's a good question.
I can take that. I can take that. Go. Yeah, I mean, that's a nice this thing. I think at that point, it comes down to how well your authentication and verification system is. It's not really about this. And Google might have measures in place to avoid spamming. It is that?
Yeah, I think you can set up certain rules. So for example, over here, they say, like, for the same IP address, they cannot create more than 100 accounts per hour. You can certainly configure that to stop spamming to some degree.
And that's like this option here, I think, applies to when users create accounts using their email and password and not relying on Google, GitHub, Microsoft, or any of the other things. And those other things that go into, like, those are SSO, OAuth, SAML, SAML.
They probably have their own way of stopping the spam, right?
Yeah, so Google might be doing something to avoid spam. If it's like, let's say, a company access infrastructure that's authorizing or doing the identity and authentication, that responsibility would be on that that entity to avoid fake accounts getting created. And apparently, Firebase has a nice system to avoid being spammed if for users who have like email and password setups.
Yeah, and a nice way.
Yeah, that's
yeah.
one of the options.
And a nice way of using Firebase is that you don't have to configure these defense or the rules on your own backend. You can simply let Firebase to handle that. And if we jump back to this page right here, basically we finished logging in, but normally for a website, once you log in, you should be redirected to a page where you have certain access, right? Even though this is a simple page app, we still want to redirect it somehow. So let's go to the documentation really quick. So for Firebase, you can always go to the documentations on the upper right corner. And if you go to build authentication, oh, that's slow. Okay, and then you see they have different documentations for different platforms. For now, let's just go into web, and then say sign in with pre-built UI. This is what the Firebase UI is doing. I think there's a section called redirect. Yeah, so here, if you copy that and paste it into our, I think it's a part of the configurations, so we can put it right here. And what this is doing is, for example, if you want to configure this app to do something differently. So for example, if the user, after they log in, you want to bring them directly to their profile page, then you can use this simple field and specify, the URL endpoint you want to point them to after they log in. Once that's done, when we sign in, that should point us to go to, localhost 8081/profile. However, since right now we don't have any subpages or router setup, it won't point us to anywhere, and we actually don't need this redirect for our purposes. But I just want to mention to you so that later down the road, if you want to use it for some other projects, such function exists. And then one thing you probably also notice is that right now we're logged in, but then it's not showing or displaying as if it has any of the user information yet. It's because we are logged in, but we're not, retrieving the authenticated user back from the Firebase Aussie anyways. So we're basically at this, we send the credentials out, we get something back, but right now we're not saving it into the Vue front end yet. But we want to essentially save the authenticated user into the Vue store. What we can do is we can go to main.js file right here under the source folder. And then previously, we just have a simple Vue app setup. However, if you go to our code snippets, so there's this method called onAuthStatesChange. So let's just copy this first, and then we'll put it into our main.js. And then we also need to reference.
Is everyone able to hear the audio? You have message. Someone seems to have lost the audio. Josh seems to have lost the audio. Could others?
Yeah, it's fine.
Oh, okay.
Yeah, I can still hear you.
So maybe it's just Josh that has the problem, I guess.
Yeah.
Okay. Then I'll continue. And Josh, whenever you fix your audio issue, we can always pull one of the following branch, and then you can still follow with us. And then over here, I also need to import my Firebase references. So Firebase from Firebase. And that should give us firebase.auth. And then whenever, so this is an event, and then it gets triggered every time, our authentication state change. So for example, once I logged in, my authentication state will change to, logged in. And then we'll have our authenticated user back at this point. And what we want to do is actually save this user instead of our global variable. So what we want to do is call store commit. And then if you remember in our Vue store, if we come from here, we already have this mutation function called set user profile. We just need to copy the name, go back to our main.js, and then give it our authenticated user. So in this way, once we log in, we'll have the user information stored globally on our front end. And then we can display it in a way that we can actually show the user that, oh, you're logged in rather than, still processing or something like that. So let's jump back to setnav.vue. We can use a f function over here. So we can say vf, and then we can say that only this, we can specify so that only show the login button when you don't have a user. And then if you do, maybe you can show something else. So let's just have a simple span tag right here now. And then we can say v else. And then we can maybe display the user's name or something. Okay, let's see. Seems I have some import issue here. Let me see. Okay. So instead of doing this, I'll just say import us from Firebase, and then I'll do this. And that should work. Let's see. Okay, so let's try. Oh, see, since we already signed in, it's not displaying our name, right? So that's good. I have some pre-built UI buttons that allow us to, handle the sign in and sign out. So let's just copy that really quick from our snippets right here. So if you scroll, so scroll up a little bit, you'll see the section called sign, login, and out UI. Yeah, and then let's just copy these things and then paste it into our setnav.vue file. I'll actually replace these things. So it should, I'll replace the entire div actually.
Okay.
Yeah.
There's a question here about random running into cause issue. Yeah, like we're laughing because we ran into the same issue and it has a fix. If you're ahead of us, you could check out the steps. At the very bottom, there's a video link of how to fix that. But hopefully before the end of the session, we are gonna get to that.
Yeah. I'm interested to see why you're running into course issue after. Are you running into course issues just by signing in, Brandon?
Already logged in and uploaded a model, so I'm going to load existing model, and I'm assuming during the fetch it's having an issue.
Yeah, we'll cover that later in the workshop, so we'll have a section that'll go over that.
Copy. Thanks.
Yeah.
You could check out the video. Like you need to do some Python and GS YouTube things.
Yeah. So right now we built in the login side of the authentication, but we haven't really figured out how to sign out yet. So let's create a function called sign out button press. I'll also put it in the setNet.view as one of the methods. And then I think in the code snippet, I have some function written out to sign out right here. So basically we need to call Firebase out sign out, and then tell us that the sign out is successful. We'll copy that, put it inside of our new function. However, since we already configured, we can simply do Firebase just sign out, and that should work. Game name, that's fine. So you see now, once you hover over the avatar icons, we have a button for logout. And then once logs out, it says sign out successful. Yeah, and then if you refresh the page, it'll just clear it out itself. So that basically covers the Firebase setup. We have a more, beautified and then put together examples. So if you go check out this branch called Workshop Firebase Setup, you'll see, the entire setup for having the Firebase auth running properly on your local machine. So let's just discard these changes really quick. And then go to Firebase setup. And then that should give us running. Yeah. So different from what I just showed, I basically building a new filter for the name so that it only gets all the initials, and then I did some CSS and HTML works to make it look a little bit cleaner. But overall, the function is still the same. So when you click on log out, you see the button reflects, and then when you log in, then it's pretty straightforward. It'll just work right away. I think that covers the step for setting up the Firebase authentication. Does anyone has questions besides the course issues that Brandon is running into?
For others, like that's an issue we still haven't run into with the workshop where we are. It's a few steps ahead.
Yeah, it's later on when you're trying to download it into the viewer, we'll probably run into that issue. Okay, cool. So if nobody has any questions, we can move on to the next section for uploading and downloading a 3DM model into the Firebase storage and database. Let's click on the step first. So, this workshop will mainly trying to focus on Firebase and threejs. So I have a lot of front-end HTML code that's already built out. I'll be copy and pasting those from the snippet. So the first thing is to have an upload UI. So let's go to snippets. And over here, there's a section called uploading, loading, and sharing UIs. Let's copy that. And then put it inside of the dashboard.view. You can feel free to put it, yeah, so these are the things for the threejs viewer settings. We can probably just put it right in front of it. These, let's bring it in, and then we'll take a look and see how it looks like. So let's just save it. Go to our localhost page. And now you see we have these two new buttons, one for upload a new model, the other one for loading existing models. We also have a button, but you're not showing it here, that handles toggling whether this project is a public project or not. We'll mention that later on. For now, we are getting an error from the button that's consuming a variable called enable share. I'll just disable it for now, so we don't see the error. Okay, that should be good. Let's just try pressing on the upload new model button and see what happens. Right now, nothing happens. Okay. Basically, what this is also a Vuetify button. What it does is when I click on it, it's setting this variable called show new model dialog to be true. So first of all, let's initialize this variable and put it into the data field. And by default, let's assign it to be a false value. This will control whether we'll have a pop-up model or not. So if we go to Vuetify and then we go to dialog, you see here basically what we're doing is we're trying to press on a button and that show us, a pop-up UI, a dialog that contains some controls for us to upload the model. And then how these things are controlled is basically these models has a property called dialog. And then in the script, basically the dialog is just a Boolean value. When it's changed to true, then you'll show the dialog. Otherwise, it'll just stay hidden. And then we also have snippets for the dialog as well. So over here, you have something called upload dialog. Let's just copy this entire thing and then paste it into right before the buttons. And then I'm just going to give it a comment really quick so that we know what's going on here. Okay. And we're probably going to miss a couple of methods. Let's see. Yep. So if we go to let's just log in really quick, sign in with Google. If we go to the demo link and log in, okay. Wow. Fine. No, it's basically I'll show a dialog that basically asks for your basic model name as well as a directory of which random model you want to upload. That's why when we take a look, we have missed, like over here it's asking for a variable that's called new model name. We haven't set it up yet. So let's just do that really quick. And by default, I'll give it a null value, which will ask and force the user to put it in before they can upload the model. Let's see what other errors we have.
Use the other demo link. There is one demo link that works if you want to use that. AECtech 2021.web.app.
Yeah, but it's because the third-party cookies that we're not able to.
I've configured it.
Okay.
Should work. If you just want a demo.
Should be okay. Yeah. And then files for upload. This is basically an array that contains, all the random models that you selected that you want to be uploaded. For the workshop, I configure in a way that we only allow one model upload at a time, but you can certainly change that later down the road. And then if you want to upload multiple models at the same time. And then what else errors do we have? Model uploading. There's a lot of beautified things going on here, so I can just comment it out. Let's see. Okay, we're good. I see. Yeah. So now we have this button working, and then when click on it, you see this pop-up UI. Basically, asks for a model name and the file to be uploaded. So we can let's just say demo1, and then for file input, we'll just choose model1. And then we can just say upload. But right now we haven't hooked up the upload function yet, so nothing will really happen. The reason why I really like Vuetify is because a lot of these preview UIs is already there. for example, this file input is actually one of the UIs that they have. So if you just search for Vue.js file uploader, and then you see that they already have these pre-built UIs that you can copy and paste. And then if we dive back to the code really quick and take a look of the file uploader here. So basically, all the files that you selected will be stored in the variable called models for upload, which is something that we set up earlier here as an empty array. And then basically it'll store it in the memory, and then the moment you press upload, it'll send it to the Firebase storage. But as you see right now, when we click on the upload button, nothing really happens because we haven't really set up this function for submit files. So let me just quickly create a new method called upload files. And then what we're going to do here is we're going to first set up our connection to the Firebase storage so that we can upload a model there. Let's go back to snippets and scroll down a little bit. Over here, see the section for upload a file to storage. And then let's just copy this really quick. Put it here. Yeah, so as I mentioned before, we can replace this just with this .storage. And then ref.child. So if I explain it really quickly, wait, let's go back to storage. And let's just try to upload a file right here. So you see, that's how you upload a file. But for organization, let's just create a model called models. And then since we have this folder created, we can reference this folder by simply calling models. And then if we know the name of specific files inside of that, we can use this child syntax to reference to that. But now, for now, we can just leave it as it is. And then over here, what's happening is we're using this put method to upload a file or a bit of arrays to the storage. We can just test this out really quickly. Let's see. So this is already connected to the upload buttons, which is great. And let's just test it out. Okay, so test 1. Right now, it won't really upload the model that we referenced. It should just upload some 8-bit arrays. Okay, now read probably define. Let's see. This .storage.ref. Let me see what I did for the setup. Okay. So previously I was doing this right. Okay. So we can bypass the ref directly and then just have a name for the child over here. So what we can do is child, and then we can just name it test1 simple. And that should work. Let's see. It's because I haven't really imported this reference in yet. So over here, I'll reference in the Firebase storage references in here, and that should work. Okay, let's just copy over the actual implementations to test it out. This.storage, we should have set it up. Yeah, I think I named it differently this time. Let's see. Firebase storage. So I forgot the name of it. Go back to dashboard and change this to FB storage as well as over here. That should work. Yeah, I'll just copy this line. So this is basically putting it into the models folder and then try to grab the name from the first file of all the random files that we selected. And then actually upload the first file that we selected to the storage. This should work. That's why pre-recorded video is better, probably.
Oh, that's good. I mean, there are some questions about like having to go through this.
Yeah.
Like this is debugging one.
Yeah. Okay, so we got it working. You see this message, loading completed. I can explain this a little bit. Are you having trouble to follow like the upload steps a little bit? I can go back and just explain things a little bit better since now we have it working.
Like I didn't understand the logic of that reference and bytes.
Okay, that was the sample snippets that provided by Firebase. So basically, over here, it's trying to create a file container called soundchild as the file name. And then this is a random 8-bit array just to representing, something that you'll be uploading as a file. And then what's happening right here is it's trying to upload to this container called soundchild, and then it's basically an upload method. And then it's uploading these bits into your soundchild container. And then once it finishes uploading, they'll send out a message saying uploaded an array. And then in our example, we have all the reference files that we have by choosing these models. So if I choose 4 models, I set up in a way that I'll only reference the first model and upload that. So basically, files for upload will have all of the 4 random files that we selected. I'll take the name of the first random model out, and then also just upload the first random model into the storage. We can take a look from the storage console really quick as well. So now, maybe I didn't press the upload button. I'll change it to test models. Save it, and let's see if we can get it working this way. Yeah, that's what's the database. Test 1. Oh, that's a PNG. Let's try something model 2 CDM.
Ahmed has a good suggestion in the thread going, like this might be a good place to implement checks on what sort of files you let the users upload.
Yeah, I think you can set up in a rules on the upload, on the put function right here.
I've done it before through just raw JavaScript from within the submit button itself, but I'm sure there are ways to do it through Firebase as well.
Yeah, I think another way you can probably do it is, when you launch this dialog, you can probably set it up in a way that it only
Yep.
only shows 3D files.
That's the simplest, probably.
Yeah. I think I'm going to jump straight to, yeah, so let's just go to the steps really quick. I think I accidentally closed it. And then let's try to reference this on this branch directly. So we'll go to GitHub desktop, revert all the changes we recently did, and then go to storage setup. Copy that. And this should have an example of both the upload and download working. Let's see. Let's just test it out really quickly. So we'll say upload model workshop demo 1, and then we'll upload model 2, the 3DM file, upload. Yeah, and then we'll see here a document written with IDs. That's good. Let's go into storage really quick and see.
Oh, that might be because when you do the checkout, you change the Firebase config.
Yes. So when I was setting up this example, I included my configuration for a different project. Maybe that's why we haven't seen the model that we have been uploading it. So let me just quickly paste over my config for this project really quick. Yeah, I just need to, like, for everyone who is pulling from the branches, make sure that you just replace this config file. Yeah. And then now it should be okay.
I mean, it's also fine, like, if you just want to use the config that we have, it's going to upload to the test project that we have running that we plan to dispose of tomorrow or sometime.
Yeah, but they just won't see it in the in the storage
on your account.
Yeah,
we'll probably get to see it on the account that we got.
Okay. Demo 1, model 2, upload. Missing or insufficient permissions. I think that's probably a Firebase storage setup. Let's take a look. Yeah. Rules. One of the rules allow read and write permissions if authentication is not. What if we remove this line really quick? And then come back here.
Should talk about it at high level, that the rules dashboard that we just saw, like over there, Firebase allows you to configure checks on different sorts of checks that you might want to impart on files uploaded on other logic.
Yeah, I think.
Oh, we got something to
allowed read and write if
true. I think
if true. So
yeah,
just say
at the end after the semicolon. Oh, not after, yeah.
And also let me comment on the parts that's writing to the database. Maybe that's giving us some permission issues as well. So in this example, I set up in a way that after uploaded to the Firebase storage, it's actually writing something to the database as well in the Firebase data connection. So I'll comment this. Not this.
Okay, he added the rule to the database, not the storage. Josh just mentioned that we are adding the if true rule to the database side and not the storage.
So now if we come, since I comment out the parts that upload to the database, then this upload should work then.
Yeah.
Let's see. It's probably finished uploading already. Storage models. Yeah, so you see it. Yeah, okay, that's good. And then we probably need to go back and set up the database rules as well. So in similar to storage, there's also a root tab in the Cloud Firestore. And then over here, it's by default false. That's weird.
I think because you started in production mode, it sets it to false.
I see. That's good to know. Yeah, I only set it up once and it's working. I was like, oh, okay, that's good. Let's keep rolling. And then let's see if this is working, and I'll explain what's happening right here. So it's S2 reference model 1 upload. Okay, so it uploaded, great. If we check storage, we see the model there, which is great. And then I think in this version, I'm also keeping a record in the database right here. So you see we have some information about the author. We have the name of the ID of the author, as well as its public field, a URL to the model, as well as the model name that's specified and the upload date. What's going? Yeah.
Sorry to interrupt. What's the author variable type when you're declaring it in the database?
Right now it's just an object that contains the ID field and name field. And if you go back to the example, let me just explain a little bit since I skipped this part quite a bit. What's happening right here is after we upload our random model to the storage, right? We get a snapshot. The snapshot is basically a reference to the model that we just uploaded. And then by pulling ref.pass, we basically get information that looks like models / models _1.3dm. Pretty much just the name of the file. We're also creating a new field called author, right? And then the author, we are pulling the ID from the author that we store in the global variable, as well as the display name of the author. We want to contain this information just in case later down the road, if you're loading a model, you can at least know if you are the author of the model or not. And then basically this JSON file in between line 189 to 195 is the content that will be uploaded to the Firestore database. And then here's a bunch of variables. Like, for example, after we upload it, we clear out the existing model name. We also clear out all the selections to the Rhino file. I think this model uploading is just like a variable that determines if you show the loading bar on the front end. Like, when you press upload, there's a loading bar that's happening right here. And then it also dismisses the dialog by setting it false. Yeah. So one thing to keep in mind is that as the mistake that happened to me earlier, make sure you set the rules of both the storage as well as the Cloud Firestore working. So that make sure that you always have permission to read and write for both locations. And that covers the step for upload a student model. We cover the steps for creating a UI, upload the models to the Firebase storage, but also keep a record of that upload and the Rhino file into the database. The next step would be downloading a student model into the viewer. If you pull the branch storage setup, then you already have that part already. So let's just test it out and see how it works. So if you click on the load existing models, you'll see the model that we just uploaded. If you press on the button, yeah, so that's where I think Brandon ran into the course issue.
Yeah.
Yeah.
I made a mistake while pointing out where the video link was. It's actually in the middle of the steps. Towards the end, there's another issue that we ran into. So sorry about that.
Yeah, and then just a quick explanation of the course era. Basically, the idea is that, you know, it's a cross-region error, which means that, you know, you're requesting. Do you want to explain it? I don't know.
Let me try to explain it. This is actually part of the security protocol, security measures that browsers implement, so that some library, front-end library that's loaded in your application cannot send sensitive information to another server. So the server can send certain header messages to allow requests from other origins. By origins here, it essentially means server locations, wherever they're hosted. So we run into this a lot, like if you're trying to do a front or exclusively front-end based applications. And since we want to make a request to the Google servers to do all the Firebase things, that runs into an issue with the server that's running on Firebase. So we try to update the CORS configuration that the Firebase server has, and that is like you need to do a bunch of things to get that setting at the right place uploaded. The video walks you through that, but essentially it's something like this. Like for any origin, allow, you could specify the methods get, post, put, and the other fourth one, delete. But that's a gist of the whole course conundrum. But you, at one point or the other, if we are building front-end only applications and you need to access multiple servers for different things, this is likely to come up. And if you all also have more info about this, we would love to learn at the same time.
Yeah. So you will find some documentations about how to fix this course configuration under storage download files. There's a section called course configurations. On a broader scope, basically you need to set this JSON content to update your Firebase storage settings and allow it to basically bypass the course error. And then in order to do so, you need a tool called GS utility. I think it stands for Google Suite utility or something like that. You can do that multiple ways. You can, depends on whether you have Windows or Mac, you can download a Google Cloud SDK, which actually require admin permission on your local computer. So for Amit and I, we don't have admin permissions for our TT laptop. So what we were able to do is to download a zip file that contains the GS utility Python libraries, and then we kind of we have a video recording of, you know, how to use the Python libraries to to update the course settings. However, if you don't want to, and the video is right here.
Ahmad also shared an article link, which I think tries to address the same problem.
Yeah. So as you can see, that's the documentation, and that's where I'm going through, you know, different options for installing GS utility. Yeah, and then what the approach we did was we download this zip file that contains the Python libraries. And then once you download it, you kind of just unzip it and put it into the C drive. And then in order to do this, you also need to have a Python installed and also have a version 3.8 and above.
And to make it more complicated, if I remember correctly, you have to download the Google Cloud SDK.
Yeah, Google Cloud SDK, you can download that, but then we couldn't do that for our machine because we don't have the permission to, the right permission to do so.
Oh, I see.
Yeah, but if you have the permission, I think the SDK would be an easier approach to do so. And then, however, if you don't want to set up this right now, I think what you, one thing you can do is if you go back to GitHub, and then maybe just revert the changes and use the configuration settings in the repo directly. That one already have the core settings updated, so you should be able to use these configs to load some models back. We can test that really quick. So I reverted my changes, and should still have some kind of configurations here. And then let me just refresh the page really quick and see if we can load existing nodes. So you see here, this is on one of the previous Firebase project we're using, so it has a lot more models. So let's just try loading up one of the models.
I think even if they upload right now, that's gonna show up here, right?
Yeah. If you upload right now, yeah, I think it'll show up here.
Please don't spam.
Oh, I already see.
Yeah.
Yeah.
I mean, up to 2030 is fine.
Yeah. I mean, we'll be deleting these projects after the workshop. So sooner or later, you have to set up your own core settings for the bucket to configure. Another way to do this without setting up the core settings, you can probably use the node backend that we already set up, and then install the corresponding Firebase backend libraries that handles the upload. So you can create an API endpoint that you call from the front end, and then just upload the file that way.
I think that's a little safer too, because what you put there was the asterisk, which allows all origins, which opens yourself up to certain security. So having your front end be white or be only authenticated to your node server or whatever backend server is probably the better way long term.
Yeah, but yeah, it is true. And then let's see, what's the next step? So now we're able to download a 3D model into the viewer. There's one step I haven't covered yet, so let's just go over that quickly. We were able to, click on the buttons and load the models, but I want to explain a little bit what's happening behind the background. So if you go back to our dashboard.view page, let's close this, open it up. We have a function called load. First of all, when you click on the load existing models, I try to pull all the records we have in the database in terms of how many models and what's their information is available. So we do that by calling this FBDB collections models. So that refers to if you have basically, if you have a collection called models, then it just refers to all the documents inside of that collection. And then from that, we basically just loop through all of the documents and then generate an array of objects that we can display on the front end. And that's how you're able to see, all of these models. And then once we have that, and then, when you usually click on one of the loading buttons, we actually loads up the model. So when this button is being clicked, it calls this method called setCurrentModels, which basically calls this load model functions. And what it does is it goes to the Firebase storage. It pulls the model URL. In this case, if you take a look of Firestore, it's something that looks like this. And then it goes back to storage, finds the same model with the same model URL. And then what it does is it gets the download URL. This is a default Firebase functions. So what it does is it just returns a URL for you to download. We actually are not downloading this directly inside of our local download folder, but rather we're just passing this URL to a method that's already in the Sui viewer that's called onClick load models. If you follow along, we already set this function up before, but it was loading up a local random model. So by passing the URL directly into this, we're no longer referencing the local random model, but rather we're just passing a URL to the 3DM loader. It's able to like download the model, add it locally to the memory, and then parse all the geometries out and turn it into threejs elements. So all the functions that's being wrote down here is the same as referencing a local model, but only difference is that instead of a local directory path, you're just passing it a URL instead. Yeah.
One thing, like right now, the files uploaded, if they have the same name, they might overwrite each other, right, on CloudStore, because we don't create the separation between which user uploaded which file.
I think when I was testing, if they have, let's say if you upload the same file multiple times to the storage, actually only keep the unique models.
Yeah.
But in the database, I'll keep different records. So you have maybe two different database records that point to the same model.
Yeah.
Yeah. So I think they're doing something smart behind the scene to make sure that you don't have duplicate models in storage.
Also, another workaround is in the reference in the storage to add a folder for each user. That way, anything they upload goes in that folder.
Yeah, that's deeper. Like when you want to set up something like a sketch fab, then it's probably better to set it up that way to have models per user, like for each folder basically. And then let's jump back. So I think that pretty much wrap up the step for downloading a 3D model into the viewer. We put this little notes here in case if you run into the course error and you want to come back to this later. We have the official Firebase documentation as well as our video recording. And then we can, at this point, I think we already checked out the workshop storage setup branch already. Let's just double check. Yes, we do. Okay, that's good. And then the next step will be one of the final steps. This is about managing sharing and access control. The example we have in this workshop is pretty simple. So if you just quickly check out that branch, just say access control. All we did is, we already have a field in the record that's called is public. So what we're doing is, if someone is not logged in, then they can see all the models that has the is public field to be true. Otherwise, they won't be able to see the models that they don't own, basically. So if we check out the localhost really quick. Now you see that all the models I see are mainly the public ones, besides the models I just uploaded myself. So there's 3 public models here and then 1 over here. And then in order to change the model settings, you can load it first. And what you'll notice is once you load the model, you have a new button show up. And then click on this button. Basically, there's a simple toggle that manage whether you want to make this true or false. And once you click save, what's happening on the background is we have a function called in the dashboard save sharing settings. What it does is, it's finding the reference to the database record by using the ID. So it goes into all the models collection and then it pulls it out using the ID. And then it calls this upload function. And then in this case, we're uploading the is public field. And then we're just uploading it using the new Boolean variable. In this case, I think we just set it to be true. So now, once we load it, you'll see that this is being set to be true again. So that's an easy way of updating one of the existing database records in the database. Another way to easily do this is you can simply manage it. If you want to do a quick change in the database, you can easily just change it. Let's say you can go into the models collection, go to the documents, and you can double click it, and it's very easy to do a quick update on the Firebase Firestore. Yeah, it's just very simple to do so. And I think one of the last steps of the workshop will be introducing how to host it, because now, even though we have a running web app going on our local host, we don't really have a good way of deploying it and then sharing it with our colleague. I think I saw. Okay, so Josh just added some documentations. So for those with permissions, install SDK, and then set the, of course, allow. Yeah, I think that if you are able to install the Google SDK, then it should be much simpler than doing the Python way.
Yeah, and I mean, like, sooner the better, because we are gonna host the project that we have on Firebase soon.
Yeah. Okay, so let's just move on to the Firebase hosting step really quickly. In order to do that, I think I already pulled from the access control branch, right? Okay, yes, I did. And then for this case, I'll actually copy back my project configurations, just in case I have all the right permissions to set up the hosting for myself. Okay, and then previously we already installed the Firebase command line tools that we need, so that's pretty good. And then let's jump back, stop our local development server, and do Firebase init. What it does is set up a JSON file, basically knowing that which files they need to host, which Firebase project of your account they should point into, and where it should be hosted. So okay, yes, and then I want to only configure for hosting. I think there's an easy way to do this. If we go back to the snippet steps, yeah. So let's just, first of all, let's do Firebase login really quick, because I think at this point we haven't logged in, and then we probably are not able to host it without logging in. So Firebase login. Okay, so I already logged in on this machine, but if you haven't, it should basically pop out a new browser window that allows you to click on a few things and make sure that your account allows Firebase access to it. And then eventually you should be able to log in without much hassle. And then assuming that you're able to log in, then the next step is do Firebase init hosting. And we're only going to set up the hosting part using the Firebase command line tools. Let's say yes. And then for our case, I'll just use the existing project. And that will be our workshop demo, the last project that we set up for this. And then yes, for the public directory, it will be the folder where we compile all the code to, which is the dist folder. So in this case, I'll just say dist. And then we'll configure it as a single page web app. And then for now, I won't connect it to GitHub. And then override for now. Okay, that's good. If we just do Firebase deploy right now, since we haven't built for production yet, we're probably just going to see a blank screen. So what I'm going to do is I'm going to do npm run build.
It might have automatically built the files after one of the npm installs we did in the process.
Maybe. But let's just do npm run build to be safe.
Yeah.
Yeah. So this will actually compile all of your Vue.js code into this folder called dist, which I think it'll show up once it finish compiling.
Those are the certain few configurations which affect, I guess, when like calling an app, a single page application, technically, like on the backend server side, all the requests, doesn't matter what path is there in the request, it's going to redirect it to serve the index.html file. And that's why here we build out the file and deploy it. So like through the process, we get to benefit both, like using the hot loading environment for developing, because that makes life easier when developing. But for this build process, optimized and better output when serving the app.
Yeah, and now after npm run build finish building, you see we have this new folder called dist. Inside of there, we'll have the HTML script file that will be served, as well as some JavaScript, some CSS file, and some other image files that we need. And then we're ready to deploy it. So we'll say Firebase deploy only hosting. And then after it's deployed, I'll give you a link that you can check it out. So in this case, it'll be our workshop demo.web.app. And then you'll see it running away. And then assuming that you have the right storage and database configuration, you should be able to upload and load models using this link now. And also,
well, there's another issue related to the third-party cookies.
Yeah.
When trying to log in with the Google Auth system, they need third-party cookie access, which some browsers may have it by default. If you have certain security configurations on your browser, they disallow third-party cookies, which breaks the Google login somehow. And that's actually the link at the bottom of the steps, where basically in your browser settings, you go in and allow third-party cookies for the Google login system to work. So on Chrome, this is like, that's the issue.
Yeah, in case if you get this error message saying that your browser does not allow third-party cookies, right?
Yeah. So you go open up the settings, and you might need to do that even for the web app that we just shared, saw built and deployed. So I basically whitelisted this to allow third-party cookies. And that fixes the login issue.
And then I'm assuming that if you don't want to enable third-party cookies, you can use other login methods without the OAuth, right? So you can still use the old, password with email helps login. I think Google also provides a lot of pre-built authentication methods. For example, logging with your phone number. I think there's also like logging with an email link as well. So I think all of those things can be, if you enable logging with email link, then it can also be pretty convenient, I would assume. Yeah, so there's definitely a lot of things to play around with for Firebase. And that's pretty much the end of our workshop. Is there anything that you have question or you want to discuss about?
I must say this has been a really great workshop, and like it's a great crash course, I must say, like of all the technologies involved. So great job.
Thank you so much. Yeah, I mean, like while we were putting together,
so many different moving parts coming together. And we were worried at the beginning a bit, like, are we gonna be able to make it in time? And so many different things to discuss and talk.
Yeah.
Hopefully the online format helped. And even if you still come across any issues or things that are not explained well enough, or something that might be done better with via video, do let us know, because that repo and that's gonna be open. And if it's worthwhile, we will try to maintain it on or keep updating it to make it a worthwhile resource for whoever wants to use it. And we would be always accessible to answer things.
Yeah. And then really check out the snippet section of the repo. It has a lot. It has even more things than the ones we haven't covered for this workshop.
Yeah.
Yeah.
I guess even a shout out deserved for all the stacks and things and like all the open source goodness that's out there. Like they really spent a lot of time building all this.
Yeah, we basically pulled from multiple different sources to put this workshop together.
Yeah.
I have a question. Can you hear me?
Yep.
Okay, so very good crash course. I'm definitely gonna have to be peeling through all this stuff after. The videos are really helpful. I was wondering, when you publish, how can you control the website location? Or assuming I'm using 3D and there's no upload, so like I wouldn't necessarily need the Google authentication. How would you control the website location?
You can still use the hosting function of Firebase, right? So you can get rid of the authentication, the login part of it, but you can still host it using the the Firebase deploy function that we just showed. And then I would assume that you probably want to purchase your own domain name and then use this add custom domain section to like configure it to have your own unique domain name rather than just sending people weird links like something that looks like this, right?
Yeah. So okay, so just clarify. So that's generated because you haven't paid for something. I haven't used Firebase.
That's generated so that you can get a quick testing link.
Yeah.
But the overall gist is that when you go to, let's say, facebook.com, right? Facebook.com, this domain name is purchased by Facebook. So typically, if you want to have your own domain name, you can go to somewhere like Google Domain, and then you can.
Right. I think it was more just that I was just confirming that the thing was automatically generated. The domain that when you publish.
Yeah.
Okay.
Firebase has this nice thing going where they have the .web.app already available, and if you start off a good like a Firebase project with a nice enough name that's available, I mean, I like anything .web.app isn't too bad, I guess. But if you prefer .com, that's an extra thing.
Yeah.
Okay, thanks. That's clear.
I think there are some questions about them.
You want to scroll up?
Oh yeah, I see. Yeah, the video recording would be available. It's gonna be edited with after the AECtech.
Yeah, we're sending them. We're compiling them tonight, and probably take a few days for editing and uploading it. But yeah, eventually I'll be posted to our TT channel that Mustafa just posted.
Yep, thanks for sharing that.
Yeah, we will definitely email everybody who sign up for this workshop with the recording links once it's ready.
Have you guys been using this in any commercial or internal capacity where you have to pay for Firebase services?
We are currently experimenting it with one of the apps that I'm aware of.
With Firebase.
Yeah. That's trying to use Firebase. Not sure how much we can talk about that right now. Like it's still at a.
Yeah, but Firebase is something we just started playing not too long ago, and then it's not in most of our production apps at all.
Before Firebase, what were you using?
Before Firebase, for like authentication, we have our own like SSO, like that's powered by what is it called, JWT tokens.
Yeah. Like the system we have ties in with the wider TT organization's authorization and authentication system, which also supports like user email password, sort of like what you see with Firebase, but it's in-house and more control over it. And in terms of stack, that I think is always a dynamic changing thing.
Yeah.
Some projects run better on a certain few things. So that eventually comes down to the project configurations and what we need on that. So I guess it'll be difficult to like talk high level, and even through this and a lot of the web, like they keep moving so fast and everything changes so quickly. But we try to stick to the latest thing that works for our applications and users.
Yeah. And then I think all of the workshop videos will be public once they're available. So you shouldn't worry too much about that. Generally, we make all the workshop recordings available on the YouTube videos, YouTube channels. I think there's someone asking about selecting a threejs geometry and manipulating it a little bit above.
Selecting and modifying, yeah. So that's an interesting thing. I'm sure everyone's gonna have like different opinions about that. But threejs for me is morely like just a way to render 3D things on the browser, less for modifying and altering it. And at that point, we start entering into the CAD and constructive solid geometry and procedural generation, like that sort of thing. That's, I guess, is like a preference, you could call it. But I guess like based on the application that you need, like let's take for example, I think knobs, let's start with that. Like knobs was good for shipbuilding. So they find a way to like formulate the geometry in a certain way. But that doesn't necessarily need to be visually represented every time. If we can do the conversion from knobs geometry to mesh, at that point, I guess threejs comes in worthwhile to display it on the web browser. However, if we're doing it on like, let's say some Python environment, or I don't know, some desktop thing which can render meshes, it's at that pipeline where it starts bifurcating. So touching on modifying geometry, I guess that again turns into an application specific of how exactly do we intend to modify the geometry, like with what intents and what purposes.
Yeah.
Hope that answers something.
There's another question about how do you go about Grasshopper like 3D configurator? I mean, I think if you want to have some of the Grasshopper functionality, you either need to have a random compute on the back end, or you need to call into services like our Swarm or Shapediver or something like that. In fact, I think Shapediver already have pretty much like a web 3D configurator that comes with the viewer. So, it really depends if you want to build something similar or just use their own ones. And then, yeah, I also check out
Superbase. Superbase, yeah, that's like a Firebase alternative. I think it's worth mentioning. Like I think Firebase, I'm not sure if it started as an open source, but it started outside Google and was purchased by Google. Yeah.
I see.
AWS, I think, has this thing that they're coming up, trying to compete with Firebase. I'm blanking on the name.
I think it's Dynamo, or I think another popular one is to use Mongo, which you can deploy anywhere.
Yeah, Mongo definitely serves out well with like referencing data and like relational aspects of data, but when coming to like large files, that's when I guess a lot of the most popular thing is AWS S3, but Firebase has that hosting storage thing that we saw. But the thing that I also think about, that I was trying to say is AWS has one thing which has all these connected Firebase sort of
behavior, like you have the database and relational things and or storage. Like you directly use S3 over there. Let me see if I can Google up the name real quick.
Yeah, and for Eddie's question
Amplify.
about
Yeah,
yeah,
someone said
yeah, and then for loading a Revit model, this is, I think threejs already have a IFC loader. So if you are able to just export IFC file from Revit, then you can load it up directly. In fact, I think this is one of the Rhino sample or like the Revit sample models that we're looking at currently.
Mm-hmm. Yeah. And I read a question about GraphQL DB. Let me actually read the question. When would you use GraphQL DB? So to the best of my understanding, GraphQL isn't a database technology itself, but it's more like a query language. So an alternative to that might be SQL, which is just a way of how we communicate the contents that we want. And similarly, on the backend, we need something which can process that query and serve the information. However, the paradigm of like the structure of your request and response, it's also an alternative to REST, I guess. That borrows and has a lot of things from like the idea of graphs and connected networks. So yeah, that's a really neat thing, but it definitely needs stuff to be built out on the front and back end. Not quite like a product in it, or I can't think of the correct word, but not like a database in itself. Okay, Amplify exposes GraphQL endpoint in front of DynamoDB. That's certain.
Yeah, in terms of IFC.js, I've heard good things about it, but haven't really tested out myself personally. But should be able to work.
Yeah, and some alternatives to threejs that I might be familiar with is like Babylon.js. That's a popular one. There was this other. Again, I'm blanking on the name. Sorry about that.
It's end of the day.
Yeah. 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 Threejs is, I guess, just one of the ways to put. A-frame is another option, which I think under the hood uses threejs, but I could be wrong on that. But it comes down to, I guess, WebGL, like things that do WebGL for the browser. Okay, some more questions. How possible is it to draw geometry, edit elements in 3D model using threejs? Are there libraries that could assist in this task? Again, I guess that becomes like the application question, because we are using threejs just as a convenient abstraction to show mesh geometry in the browser. But when we talk about editing and updating the geometry, it comes down to like how you store the information. Like if it's mesh editing, I guess that would be the most easiest thing to start off with. And the things that you might want to look into is constructive solid geometry that can do other things, not just meshes, but the output can be interpreted as meshes. And there's this threejs library which can work with threejs, which does that. Can you do CSG threejs? CSG. G for
J or G?
G for Google. The first one might be an example.
I think it's the NPM. No.
Yeah, so at this point, like you're really working with editing geometry in the browser. And this is, I think, one of the examples. That whole aspect gets sometimes computationally heavy, and that's why the development of these technologies on the browser side has been not quite as forward as maybe on the desktop, but things like Rhino 3D.mjs, like that compiling to be compatible with threejs makes that jump for us. Another one is, have we hit a file size limit for Rhino or Revit? Do you mean like uploading files to the Firebase storage for viewing? I guess that again varies a lot based on which machine I'm looking at and like what I'm using.
Yeah.
So
just for threejs, right? Like in the Mirar, which is the 3D viewer web app that we have for Core Studio, we use streaming to tackle the large model problem. So sometimes we'll hit a moment where you just couldn't load all the model elements into the scene, right? And we're also like deliberately choosing only to load in the model that's in front of your camera rather than the ones that's outside of your camera and things like that. But I mean, eventually you run into a case where the model is too big.
Yeah, and like it becomes difficult to answer that because the answer varies so much based on which machine you're looking at. Like my older laptop couldn't handle like even a small model, but with a better newer one, that works much better. At the same time, there's stuff definitely that you can do while you're building your viewer to optimize. Like I guess the one we demoed today might not be the most optimized to render a lot of geometries, but if you start checking into instanced meshes and like calling works by default, but you could use a lot of other techniques to getting the performance improvement. But out of the box, I mean, finding difficult to answer that question because it varies so much.
Yeah.
Okay, that's a good answer we get. So Brandon shares browsers would complain around 1 GB model memory size. You can have a memory overflow or really slow model depending on lighting materials. Yeah, the lighting materials also, that makes a big difference. So if you wanna try to do something realistic, that's way more expensive and slow, and hence you have lower limits.
Yeah, what I've seen is that, right, you can have like a decently sized model that's not gonna crash the browser on memory, but then you could have a really slow model depending on your lighting materials and depths that you're rendering out.
Absolutely, yeah.
The streaming is a really good idea. It offloads the client off the client, and then you're just worried about handling your cloud hardware, or your cloud hardware is much more stable than the private client side.
Did you say like streaming the visuals in?
Yeah, I think that's an interesting. That's a good way through it, because you can never tell what your client's going to be having on their side. They could have a Chromebook that has no memory. If you're streaming it straight to them, you're handling that hardware issue on the cloud or wherever your servers are located.
That's right, and I think like that's the whole approach that Google Stadia, however they call it, tries to do. Like
the gaming platform.
Yeah,
but like not relying on your local hardware for the gaming.
Yeah, but I mean, worth mentioning, like besides the machine that they set up to render things, Google also has a lot of big infrastructure where like a lot of the CDNs are connected by they use a different stack than HTTP TCP. That's more optimized to send things on the file on the pipe quickly, multiplexing data channels. So it's not like just one thing and connecting back and forth, but they try to optimize every square inch that they can get.
Yeah.
I think I've seen like one project on the threejs forums where someone was trying to do something similar with like streaming threejs content or running on a cloud somewhere else. But I'm not too sure what happened with it or the latest on it.
Yeah, David, if you're interested about like the AECtech, maybe you can like do that for like a hackathon project this weekend or something if you're joining us for the hackathon.
I know this might be slightly off topic. I know Shapediver has a Rhino plugin to save a model as GLTF. Are you two, or is anyone aware of any other methods or plugins to do that conversion on the fly? On the fly being like on a server, because you can create buffer geometries pretty easily with the Rhino common. I think Luis Vergara created, but I haven't seen GLTF. I'm curious if anyone's found anything.
So you're asking like if there's anything we can use to convert geometries to GLTF on the server?
Yeah, without having to write your own plugin.
Yeah, I think there's, we have been working with Shapediver for the past years, and then besides the Rhino client, we now have a Grasshopper client that basically works similarly as the old Swarm. They also have SDK for viewer and compute for Shapediver. I think if you call into either of the package, especially the viewer one, I think by default it returns SDTF
Shapediver transfer format.
Yeah, which might contain GLTF. Or if you just use the compute SDK, then you can just use the Grasshopper component that converts geometry into GLTF, and then ask that you spits back the GLTF files when it returns. If that makes sense.
Yeah, that makes sense.
Yeah. And then in terms of those two packages, I think they're pretty new, like a couple months old. So I don't know if they have very good documentation about those yet, but have you used it? It's actually pretty useful. So if you actually want to do like like a 3D web configuration, like Grasshopper-like things, it's pretty useful to do that as well.
That looks neat.
Is it different viewer library?
Sure, that's something that streaming visuals.
Yeah, definitely a lot of interesting discussions, and then more libraries to check it out.
Yeah, I think it's endless.
Is anybody doing the hackathon this weekend?
Yeah. One last question is,
yeah,
if maybe like I'm quite imagining in like drawing in 3D environment. So like how would you go ahead to draw like polygons or various shapes with a mouse in 3D environment? Would you use Rhino 3DM.js and their functions for basic, or are there any other libraries?
I think there's actual like Rhino 3DM examples of drawing Bezier curves if you just Google that. If I remember correctly, what it's doing is, let's say if you draw like 4 points on the screen, it just basically takes the location of the points and then construct, a Rhino nerves curve. And then in order to render it, they basically convert it by turning it into like a somewhat continuous looking polylines, and as a threejs elements, and they just add it to the scene. So that's something I've seen done that way, but I don't know if that's the best approach or like the most efficient approach of generating geometries in the viewer. Yeah, something like this.
This one's popular, but yeah, this does like only meshes. I think you can't quite do a line, although 3ds does support lines, but I'm not sure if it's in here somewhere. Yeah, like this one that's available, the threejs editor, which is again quite popular, does the basic types that you would see mostly on threejs.
Yeah.
And outside of that, like it's more about serialization, like when you store it and what you want to do with it. Because just out of the box, I think P5 would do, but that's only 2-dimensional. And this is again still a library, and you would need to build out what you want to take from this?
Yeah, like I was tinkering with P5 to do sketch, and it
Mhm.
stores like value, like if on mouse clip store in like a black color pixel, and it's just like RGB values, like in order like for geometry, like post processing or manipulation, like SVG might be a better data. But then
Mhm.
also like how to convert that sketch into that refined and SVG curve, and then create like 3D geometries out of it.
Yeah, I hear what you're saying. I guess like the more ubiquity of two-dimensional drawing apps is because everyone's sort of familiar with images and rasterized versions of it. But when it comes to 3D geometry, the vector version of it is more prevalent, and everyone has a different structure of how they want to store their vector information. There's some good tools being discussed on the chatter over there. Speckle, Power BI, Tracer.
AECtech. Pretty sweet.
Mm-hmm.
Yeah, I'm if you have time, like can you deconstruct this, like for all the different objects and elements they have, like how what type of functions or library they might have used?
I mean, that would be shooting in the dark, but I could sure take a stab at it. Yeah, like all the BIM things makes me think this is like more IFC specific. Like IFC.js, I think can do doors and stuff. But this looks pretty neat.
Yeah.
I'm not too sure. Like Autodesk had a thing earlier which had their own CAD kernel. Let me see if I
Is
can.
it Forge?
No,
Oh.
like it could do like simple things, but yes, I'm sure. Like for rendering, showing it threejs is fine, but like understanding where you like the properties of a door and how that embeds, that's a bigger, deeper question.
Is AECtech open source, or is it just a product that's on built?
I don't think they're open source.
Okay. Yeah. It'll be nice. It'll be neat if it's open source.
Yeah. They don't publish much about how they created this either.
Mm-hmm.
Yeah, that's anyone's guess.
Even Canva's web editor is amazing.
Canva?
Yeah.
Which one did you say?
Is it Canva? Oh, Canva.
Canvi. I think there was one that I. CNVA. Oh, not that one, I guess.
Yeah, I think the first one.
Oh. Well, it's pretty nice. It feels like Vectorworks, but online kind of.
They have some demos on their Twitter.
Mm-hmm.
I think AECtech had really good 3D that you could spin up compared to what Kanoa does, at least at the moment. But Kano is all about the low carbon, whereas I think Arcologic is just about creating a floor plan.
I see. Interior specific.
So it's more like a design tool, I guess.
This was making me think. I thought the Arcologic was at the Speckle conference a couple weeks ago. Maybe I'm thinking about somebody else, but yeah, somebody had something that was similar to this, and they were talking about that they were, at least I thought it was the same company. They were just focused more on trying to target owners of multi-story buildings rather than anybody else.
I think it was Archistar.
Oh yeah, that could have been it. The problem is that everybody has to have Arc in their name, so they're all the same.
Yeah, see, Arcologic looks pretty cool. Floor plan SDK split. This is nice.
Yeah. Nice lighting and stuff by default. Even the shape diver viewer looks pretty neat. Support materials lighting.
Yeah. I think Mira was able to import some point clouds, right?
Maybe, I'm not too sure. I personally have not worked with a lot of point cloud information.
Yeah, so I guess the summary is we don't really have experiences on cloud. But I guess this basically just managed the conversion from the .pcd file. Yeah. I mean, I think threejs do support point cloud as a threejs type, but how you import it or how you convert it is a different question.
Yeah. Because even with a lot of the apps that we're building, Mira wants to swap. Like threejs has been what we use to visualize the building information that we got, and could be in different contexts. And the app, the way the user interacts and what they expect out of an application informs how we store the information about it and recreate it. Chilling.